Hello everyone, how is your preparation for upcoming physics exam is going on? Is it very good? Then don't worry. Okay, if it is not good, then also don't worry. Just stay relaxed. Okay, don't worry too much. Here I am to help you with the all revisions of all the important questions that may come in your upcoming PU2 final physics exam in 2 days. So let's start without any delay that what all we are going to discuss. We are going to discuss very important MCQs. Okay, we will also discuss very important 2-marker, 3-marker questions as well as 5-marker derivations, and if we get some time we'll also discuss a very few important numerical questions so that you are ready for your final exam. So let's start with the MCQ as usual. In my sessions, if you are following my sessions, I generally start with MCQs, then we go to the 2-marker, 3-marker sections, and then at the end derivations and numericals, right? So there is, without any change, we will start with the MCQs first. So first question is dash placed in an electric field experiences a force in the direction opposite to the electric field. So if there is an electric field, we know that negative charge experiences force in the opposite direction of the electric field. If the charge is negative, it experiences a force in the opposite direction. If the charge is positive, it experiences a force in the direction of the force, right? So here if you see electron and electron are positive charge and neutron are proton. So positive charge and proton are positively charged, neutron is neutral, so only electron is negatively charged, so electron will be experiencing a force opposite to that of the electric field. What is next? When a free electric dipole placed in a non-uniform electric field, the dipole will experience both force and the torque. Only force but no torque, only torque but not force, neither torque nor force. So what is the electric field? Let us look into the first. So it is a non-uniform electric field. Okay, so non-uniform electric field means it will experience both force and the torque. If it is a uniform electric field, it will only experience force but no torque. Sorry, if it is a uniform electric field, it will only experience torque but no force. Okay, force will cancel but torque will still be there. But if it is a non-uniform, it will not only experience force, it will also experience torque. Both will be experienced. Now let's see the question number 3. The potential energy of an electric dipole placed in an uniform electric field is. So potential energy of a electric dipole placed in an uniform electric field. So it is a potential energy. Potential energy is a scalar quantity and it is a dipole. So dipole means only P and E are should be there. So in the relation, if you see P cross E is basically a vector quantity, so definitely this is not a possibility. This is the energy density in case of a capacitor. This is the energy stored in a capacitor. So both are not relevant here. Only relevant answer is minus P dot E. So this is a scalar quantity. Potential energy is scalar quantity. So answer is minus P dot E. Question number 4. An electric dipole is placed in a uniform electric field. The dipole moment makes an angle theta with the electric field. For what angle theta is the potential energy of the dipole is maximum? So again, potential energy is basically, if you have seen that potential energy is basically minus P dot E, that is minus PE cos theta. Okay, so what is the this is a negative term, remember. So maximum potential energy means cos theta has to be minus 1. Okay, so if cos theta is minus 1, then what is the potential energy? In that case, potential energy will be plus P. That is the maximum possible value, right? So when the theta is equals to 180 degrees, we get cos theta is minus 1. So angle theta will be 180 degree for maximum value of potential energy. Okay. Minimum value is possible at theta equals to 90. Sorry, not theta equals to 90. Minimum value is possible when it is negative value, that is cos theta equals to 0. In that case, you will get minus P. That is the minimum value. 0 is not minimum. Okay, because negative PE is much less than that of the 0. if they say when it will be 0, then it will be theta equals to 90. Okay, so potential energy will be 0 at theta equals to 90, maximum at theta equals to 180 degree, and minimum at theta equals to 0 degree. So this is a very important concept, you have to remember that. Okay, so maximum at theta equals to 180 degrees, okay, minimum at theta equals to 0 degrees, and 0 at theta equals to 90 degrees. Okay, and 0 is not minimum in this case. Now, in identical cells of each EMF E and internal resistance R are connected in series, and external resistance R is connected in the series with this combination. The current through R is, so we have how many of the cells? We have n identical cells. Okay, they are all connected in series. Okay, and we have an external resistance capital R. Okay, and each of them has epsilon and not epsilon, sorry, EMF E and internal resistance R. Each of them has E comma R, E comma R. Okay, so on. Now, in cells connected in series, what is the equivalent EMF? Equivalent EMF will be E plus E plus E dot 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 E, n times, right? So this is the equivalent EMF, that is n into E, right? So this is the equivalent EMF. What will be the equivalent resistance? R plus dot 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 R, right? This is the equivalent resistance, that is NR. So what is the total resistance of this circuit? Total resistance is the equivalent internal resistance plus the external resistance, that is NR plus R. So what is the current? So current will be E NE, that is equivalent EMF divided by total resistance, that is NR plus R. Okay, this is the current in the circuit. It will be NE divided by NR, N into small r plus capital R. So option A is the correct answer for this question. Okay. Now, if you are preparing for your KCET after you have completed your PU exams, then definitely you have to look into our Abhyas KCET test series. Along with that, we also have Laksha KCET test series, which is a residential program, whereas Abhyas test series is a test series where you can get 35 well curated question papers. Out of that, 4 are free, which is already live in our portal. If you have not checked that out, you can go and check that out once your exam is over, and then you can decide whether to purchase it or not. The current price is 1498 plus 1 rupee for your PU test series. PU test series we launched a few times back, but right now I don't think you want to buy PU test series, so you can save 1 rupee and you can purchase it at 1498. The link is given in the description. Once the lecture is over, you can go and check that out. Okay. So what all you will get, the features are written over here, and in the link below, when you go to the link, you will see that what are all the features that we are going to give you. Okay, also Laksha KCET practice, that will be a crash course, Laksha crash course, where you are getting 21-day fully residential course, or you can be opting to a day scholar if you are based in Bangalore. If you are outside Bangalore, you can opt for the crash course as well. That will be a fully residential. You can come here in our campus, you can stay and you can study with most experienced teachers. Okay, so whatever you want to do, you can check that out as well. Now let's start with Kirchhoff's first law, that is sum of current I equals to 0 at a junction. Junction rule or KCL deals with the conservation of, so junction rule or KCL. So it can be come as a junction rule, it can come as a KCL, it can come as sum of I equals to 0. So that is basically conservation of energy. So first Kirchhoff's law, that is Kirchhoff's current law, or Kirchhoff's junction rule, is based on the conservation of charges, where the second law, Kirchhoff's voltage rule, is based on the conservation of energy. Okay. Now if in the experiment of Wheatstone bridge the positions of cells and galvanometer are interchanged, the balance point will remain unchanged, depend on the internal resistance of the cell and the resistance of the galvanometer, none of these. Okay, so even if you change the combination of battery and galvanometer in the balanced condition, the condition of balance remain unchanged, so it does not change based on the relative position of the galvanometer and battery. So if you change them up, the condition will remain the same. Okay, now let's see, this is a match the following kind of question. So there are a table: relaxation time, drift velocity, current density, electrical resistivity. Now as I said, if you don't know this kind of questions, you just check whatever you know. Okay, whatever you know, based on that you can answer the question. Okay, so first of all, current density. Current density is J. Current density J, can you see anywhere? So here it is, J itself is present. So how can you find current density from here? So current density J means we know that I is equal to NEA VD. Okay, so current density J is basically I by A. So if you see that, that will be NE VD. Can you see anywhere NE VD? So current density J is basically given over here. So it is current density J. So I know few, whatever I know, I will try to match them first. Next is electrical resistivity. So electrical resistivity means rho. Now we know that E is equal to sigma, J equals to, we know that J equals to sigma E, right? So J equals to sigma E. So if you see that this quantity is very, very tempting, so 1 by sigma equals to E by J. Okay, so what we have done the cross multiplication. Now 1 by sigma is nothing but the resistivity. Okay, so resistivity is basically 1 by conductivity, that is E by J. Okay, so this is the another match that we have found. So now after matching at least 2, you can check if you are getting anything correct or not. So if you see that the combination of there is one more mistake over here. This should be 1, 2, 3, 4. Okay, now if you see this matching, 4 is matching with B and 3 is with A. Now if you see that 4 is matching with B, there is only one option where 4 is matching with B. Okay, and 3 with A. So definitely this is the correct answer. So option B will be correct matching. You can check the rest one, that is 1 is matching with C. So 1 is matching with C. So relaxation time expression is this, and obviously this is relaxation time, so it cannot match with something which already has relaxation time, and drift velocity is matching with this. So this is the drift velocity. Okay, so as I said, always try to find at least 1 or 2 known quantities, and from there you have to try to match. This is a very difficult type of matching, and you can expect one difficult matching coming in your upcoming PU exam, because they have given a lot of matching questions in your model question paper, in your question bank. So I can expect at least one good matching question in your PU board. Okay, previously there was no matching question came in your last 2 years where we are seeing the MCQ questions, so that was not there, but this year there is a high chance there will be a matching question. Now question number 9, statement based question. Statement 1, a current carrying wire is placed parallel to the magnetic field, then the force on the due to the magnetic field is 0. So a current carrying wire is basically kept in the same direction as the magnetic field. So this is current carrying wire carrying current, this is the magnetic field, the force is basically saying 0. Okay, the net charge on the current wire is 0. So net charge on the current wire is 0, but there is nothing to do with the net charge. The force that acts on a current carrying wire is based on the fact that there is a moving charges, and those moving charges experience force. But from Lorentz force, we know that Lorentz force is given by QVB sine theta. Now if they are in the same direction, that means motion of electron motion of electron may be anti-parallel. Okay, motion of electron is basically in the opposite direction. So motion of charges, and the angle is basically anti-parallel, means the angle is 180 degrees, sine 180 degrees is 0. That is why it is 0, not because of the net charge on the current wire is 0. So this is a correct statement. This statement is correct, this statement is correct, but it is not the correct reason. Okay, so both statements 1 and statement 2 are true, but statement 2 is not a correct explanation of statement 1, so option B is correct. Okay, so option B is correct. So be careful, these are the very tricky questions, statement based questions. Okay, even if they appears to be correct, sometimes they may not be correct, so you have to be extra sure before you answer statement based questions. Okay, now another matching. In the following table, column 1 lists magnetic substances and column 2 lists some magnetic properties of the substances. Okay, again as I said, if you don't know, that is fine. If you don't know all the matchings, that is fine. You have to identify which one you know. Okay, so here you have diamagnetic, paramagnetic, ferromagnetic. Okay, so now definitely we know that domain formation happens only in ferromagnetic substances. So definitely this is a correct match. Okay, now if you see the options, there are two options with C matching with Q. So you have to find one more match. Paramagnetic substance is basically where the relative permeability, susceptibility is greater than 1. Okay, and diamagnetic substance has negative relative permeability, that is mu is less than mu naught. Okay, so diamagnetic substances is matching with P, so A is matching with P and B is matching with R. So correct answer is this one. Okay, option B. So A is matching with P, B is matching with R, and C is matching with Q. So whenever you see such questions, exact this question may not come obviously, but whenever you are seeing such question, first try to find out whatever you know, and based on that you try to find out if are you able to answer this question only based on one match or not. If you are not, then you have to check what else you can find out. So based on that you can answer these questions. They are tricky but answerable, not not answerable like that. Okay. Now next is the ratio between magnetization and magnetic intensity. So magnetization and magnetic intensity is basically magnetic susceptibility. Okay, so it is a dimensionless quantity. So magnetic susceptibility is a dimensionless quantity. So the answer for this question is dimensionless quantity, not the reciprocal of susceptibility. Very careful, because ratio of magnetization and magnetic intensity is called susceptibility itself, which is a dimensionless quantity. So answer is dimensionless quantity. Now, if a magnetic substance is kept in a magnetic field, then which of the following substance moves out of the magnetic field? So moves out means it repels the magnetic field. Only diamagnetic substances repel the magnetic field. So answer is diamagnetic substances, and in this case superconductors are an example of perfect diamagnetic substance. Okay, superconductors are example of perfect diamagnetic substance. So superconductors come out of the magnetic field. So this is also a very interesting and important question in my opinion. Right, let's see the next question. In the direction of direction of the current induced in the loop ABC shown in the figure. So this is a very tricky high level HOTS question. So here we have a current direction in this direction. So what will be the direction of magnetic field? So if you see the direction of current in this line, then the direction of magnetic field will be into the page of the paper. Right, into the page of the paper we generally denote with this cross. So all the magnetic field lines passing through this circle is basically into the page of the paper. Now remember that if the current remains constant, there will be no induced current. So only when the current changes, there will be an induced current. Okay, now how to know which direction will be the induced current? If current increases, the induced magnetic field will repel the original magnetic field. Okay, if the current is increasing, that means the induced magnetic field will be out of the paper. Okay, if current increases, if the current decreases, then the induced magnetic field will be in the same direction of the original magnetic field. Okay, these are the two things that you have to remember. Okay, if current increases, then it will oppose. If the current decreases, then it will support. Okay, so if the current decreases, it will be in the direction same as cross. If it is increasing, then it will be dot. Now what do I mean by dot and cross? So if dot means out of the paper, so out of the paper means the magnetic field lines will be out of the paper, so current will be in this direction, that is A, C, B. So if current is increasing, that means it will be in the direction ACB, because magnetic field will be out of the paper, so it will be ACB. If current is decreasing, then it will be the same direction as the original magnetic field, that means the current magnetic field lines will be into the page of the paper, so the direction of current will be like this. Okay, so it will be ABC. Okay, it will be ABC. Okay, now let's see what are the options given. Along ABC, if it is increasing, so we have found out that increasing means ACB, so definitely this is not correct statement. Okay, increasing means only ACB is possible, so it is not possible. Along ACB, if it is decreasing, okay, along ACB it is increasing, so this is also not correct. Along ABC, if I is decreasing, so as it is decreasing, it is along ABC, so this is the correct option. Along ACB, if it is constant, if current is constant, no current, no induced magnetic field is happening, so this is also incorrect. So option C is correct. This is a higher level HOTS question, and it previously very long time ago came in a one KCET exam, but it is there in your question bank as well as in your one of the model question paper, I think model question paper 2, but in that model question paper 2 the options were given incorrect, 2 are correct answers, so it might come in your board exam as well. Okay, so you have to be prepared for this. The names might change, okay, the original direction of current might change, the orientation might change. For example, in the KCET exam, what I was talking about, the diagram was given like this. Okay, A, B, C, like that it was given. Okay, so orientation might change, but you have to remember that if the current is going in this direction, always point your fingers in the direction of current, then find the original magnetic field. So original magnetic field will be into the paper if this configuration is given. Now as I said, you have to remember two things. If current is increasing, the induced EMF will be such that it is opposing. If the current is decreasing, induced EMF will be such that it is actually supporting the original magnetic field. That is the main two things to remember. Now, phenomena of induction of an EMF in a coil due to change in current through the same coil is called mutual induction, self-induction, motional EMF, induction of magnetic field. So it is called self-induction, same coil, so change in current in a same coil, so that means it is a self-inductance. Okay, the input voltage to a pure inductor V equals to Vm sine omega t, then the current in the circuit is. So pure inductor means the in case of pure inductor, the current actually lags by pi by 2. Okay, current lags the voltage by pi by 2. So if this is Vm sine omega t, that it will be Im sine omega t minus pi by 2. Lags means negative, lags means negative, leads means positive. Okay, and be careful, if this is sine, this has to be sine as well, cos is not correct. Okay, so correct answer is Im sine omega t minus pi by 2. Okay, in series LCR circuit, the L and C are interchanged, the resonance frequency of the circuit will be. So as you know that in series combination, the relative position does not matter as long as the values are same, it will remain unchanged, so it will remains the same in this case. Okay, so even if you change L and C, the resonance frequency will not change, it only depends on the values of L and C, it does not matter how you have connected. displacement current is produced due to constant electric field, constant magnetic field, changing electric field, changing magnetic field. So displacement current ID is basically given by epsilon naught d phi E by dt. Okay, so displacement current is basically when electric field is changing in the circuit, then you see displacement current. Choose the false statement. Okay, very important, another type of question, false statement. So that means 3 statements are correct, only 1 is incorrect. Okay, so electromagnetic waves are produced by accelerated charged particles, correct statement. For electromagnetic waves, E naught by B naught equals to C, where E naught and B naught are electric and magnetic field amplitudes. This is also correct statement. Electromagnetic waves are transverse in nature. This is also a correct statement. Electromagnetic waves can be deflected by electric field and magnetic field. This is not correct statement, because electromagnetic waves cannot be deflected by electric or magnetic field. Even though they are being produced by electric and magnetic fields, they cannot be deflected using electric and magnetic field. So option D is the incorrect statement or the false statement. Okay. In refraction of light, sin I by sin R equals to 1, I by R equals to constant, sin I into sin R equals to constant, sin I by sin R equals to constant. So obviously easy question. This is Snell's law, sin I by sin R is constant. Now, for total internal reflection of light, light should travel from rarer medium to denser medium. Light should travel from denser medium to rarer medium. Light should incident along the normal. The angle of incidence should be equals to 90 degrees. So only 2 conditions are there for total internal reflection. The angle of incidence should be greater than the critical angle, and the light ray should travel from denser to rarer medium. So light should travel from denser medium to rarer medium. Option B is correct answer. While both light and sound show wave character, diffraction is much harder to observe in light. This is because sound and light both show diffraction. Diffraction basically when you are speaking to someone standing other side of a wall. Okay, there is a wall. Suppose there is a boundary wall. You are talking to your friend who is standing outside. Hey, I don't come to play today. I have physics exam upcoming. So basically that the sound your friend is receiving from the other side of the wall. Okay, he has exam. So that's called diffraction. Because of this sound having a very large wavelength, it can cross very high or very thick boundary walls as well. Okay, so that is why diffraction is much more common in sound than that in light. Okay, so wavelength of light is very small or far smaller. So that is why we do not see diffraction as commonly as in case of sound. Okay, in fact we sometimes forget that even sound shows diffraction because it is so normal for us. Okay, but sound do show diffraction and is very common. That is why we take it for granted, right? Which of the statements are correct with reference to single slit diffraction pattern? Fringes are of unequal width. Fringes are of equal width. Light energy is not conserved. Intensities of all bright fringes are equal. So here we are talking to single slit diffraction. So fringes are not equal width, and their brightnesses are also varies. So fringes are not of unequal width is the correct answer. Don't fall for the trap. Many students will answer option D, but that is for double slit experiment, Young's double slit experiment. But for single slit experiment, fringes are of unequal width. If the same question was asked using Young's double slit experiment, then fringes of all the bright fringes are equally bright. Okay, all the dark fringes are equally dark. Now, the source of alpha particle in Geiger-Marsden experiment is bismuth 214. So this is the correct answer. According to classical theory, the electron will fall into the nucleus. An accelerated electron emits radiation in circular path. Yes, so according to the classical theory, accelerated electron, when it is orbiting in the circular path, because it is accelerating, centripetal acceleration is acting on it, and it will slowly lose the energy. So that is why electron will fall into the nucleus. So both 1 and 2 are true, and 2 is the correct explanation. So option A is correct. Now let's look into a trial fill in the blanks. Obviously fill in the blanks question you cannot expect to come in common. The entire textbook is there, but generally fill in the blanks question are relatively easier to answer. You can again use your logical thinking to answer fill in the blanks. Even if you don't know it, try to find whatever answers you know. Okay, then leave the rest for the last. Then try to guess the last two answers even if you don't know what are options left. Okay, so only one option, if the option is used in one of the answers, then that will not be reused. So the other options whatever left, one of them will be correct answer, right? So they are, previously they used to give 5 options, 5 fill in the blanks. Now they are giving you 6 options, 5 fill in the blanks. So one option will be extra, and that one might be tricky for you to answer. So a galvanometer can be converted into an ammeter by connecting a small shunt resistance to the galvanometer. Okay, so galvanometer can be converted into an ammeter by connecting a shunt resistance in series. Okay, ammeter means shunt is always connected in series. Okay, so option will be series. Answer will be parallel. Okay, so this is the main thing. When you are converting a galvanometer into a ammeter, okay, the resistance should be connected in parallel, right? So that the current, most of the current passes through the shunt, and the total resistance of the galvanometer remains low. Okay, so these are the trick. Okay, so series will not be an answer. Now series will not be an answer means parallel will be the answer, right? Now let's see the other options. So there should be other options, should be easier. The magnetic flask associated with the coil carrying current is directly proportional to the dash. Okay, so magnetic flask, what we are talking about, magnetic flask, okay, associated with a coil carrying current is directly proportional to, what is directly proportional to? Obviously it should be proportional to the current flow. It should not be proportional to superposition, it should not be proportional to tetravalent, it should not be proportional to inwards. Okay, only thing that can be proportional to is current. So correct answer is current. Interference of light is due to dash of identical waves traveling in the same direction at small angles. So interference is not related to tetravalent, interference is not related to inwards. Okay, it must be related to superposition. Okay, so you just try to make the sentence complete with proper meaning, then you can find the answers even if you don't know the fill in the blanks. Now next 29, electric lines of force about a negative point charge are radial and tetravalent. Is it making a sense? It is not making a sense. So electric lines force about a negative point charge are radial and they are inwards. So negative charge are always inwards. So inwards will be the correct answer, right? Again, silicon is a dash crystal, silicon is a tetravalent crystal. So in case you don't know any of the answers, you skip that part, you go to the next option, next option, next option, and then at the end you come back to the unknown part and try to answer it whatever options left with it. Okay, so this is a trick, this is a tip for answering fill in the blanks in case you are not sure. Let's move on to the 2 or 3 marker question. So this is as usual combined section, because sometimes 2 marker question can come as a 3 marker question, 3 marker question can come as 2 marker question based on the depth of the question. Okay, first is a 2 marker question. This is a 2 marker question, but if they ask the same question with vector form, then generally it will be a 3 marker question. Okay, state Coulomb's law in electrostatics and explain the case of free space. So obviously in case of free space you have to mention the permittivity of free space, very very important. So Coulomb's law states that the electrostatic force between 2 point charge is directly proportional to the product of the magnitude of 2 charges and inversely proportional to the square of the distance between them. Now Coulomb's law in vector form is generally this. In this case it is optional, you can write this form or you can write the normal form. In case of free space, obviously you have to mention 1 by 4 pi epsilon naught. Okay, that's it. So free space means you have to mention that entire term. Obviously this should be explained. Okay, that is the main thing. Now question number 32, charges are additive in nature, explain. So if a system contains, so basically it is like there are three properties of charges, right? So one of the properties, charges are additive in nature. So in this case they are asking you that explain that. So how to explain it? Obviously that is why I say you study a little bit deeper. I see that students, when it comes to the property of charges, they write charges are additive in nature, but they don't know what is the meaning of additive in nature. So when they ask the same question, but here they ask you elaborate it, students are not able to answer it, okay, because they only remember that charges are additive in nature. So they will write the answer charges are additive in nature. You will not get any marks, because they have not asked you the statement of properties of charges. They have asked you to elaborate it. So whenever you are studying, if you study just only limited information, then you will not be able to answer questions which are slightly deeper level, okay. That is why you have to study a little bit understanding level. For example, what is the meaning of quantization? Charges are integral multiple of a fixed value, that is 1.6 into 10 to the power of minus 19 coulomb. Okay, so that is the main thing that you have to learn. So whenever you are studying the same thing, study in salpa detail, so that you don't miss out on important if the question is slightly tricky, slightly not common. Okay, if a system contains 2 point charges Q1 and Q2, the total charge of the system is obtained by simply adding algebraically, that is Q1 plus Q2. That is, the charges add up like real numbers, or they are scalars like the mass of a body. Okay, so this is how you have to write the answer. The total charge of a system containing 5 charges, say 1 plus 1 plus 2 plus minus 3 plus 4 and minus 5 in some arbitrary unit, is basically plus 1 plus 2 plus minus 3 plus 4 plus minus 5 equals to minus 1 in the same unit. So this is how you find the charges, total charge in a body. Okay, so charges additive in nature means it is basically like your exam marks. Okay, if you score 0, 1, 2, 3, all the marks are getting added, right? So this is the same thing with charges as well. So if you give different values of charges, even if they are negative charges, you can simply add them algebraically. Algebraically means 1 minus 2 is minus 1. That is algebra, right? Now, derive the expression for torque on a electric dipole placed in an uniform electric field. This is a 3 marker generally. So we have, but may come as a 2 marker as well. So we have electric dipole. So this is a plus charge plus Q. This is a minus charge minus Q. Now, positive charges always experience force in the direction of electric field. The value of electric field is E. Okay, diagram is compulsory in this derivation. Diagram is compulsory. Okay, now what is the distance between them? So this is the A, this is A, so total distance is 2A. This angle is theta, then this angle will also be theta. So this will be 2A cos theta. Okay, so this is 2A cos theta geometrically, right? Because this is base, sorry, this is hypotenuse, this is base, this is perpendicular. So it, sorry, 2A sin theta, perpendicular, right? This is perpendicular with respect to this angle. With respect to this angle, it will be a perpendicular. With respect to this angle, this is perpendicular, right? This angle is 90. This is the angle. This is perpendicular, so this will be sin theta. Right, now what is the force acting on the charges? Both forces are same. If this is F, this will be also F. Both forces are equal in magnitude. Direction will be different, but magnitude wise both forces are same. So what is the force acting on a charge kept in a electric field? The force acting on a charge kept in an electric field is basically magnitude of the charge times the electric field, that is Q into E, right? So force acting on a charge is Q into E. The distance between the charges, the perpendicular distance between the charges is 2A sin theta. So torque acting is basically F into the distance. Okay, so F is Q into E and the distance is 2A sin theta, or Q into 2A E sine theta. Now charge into the distance between the dipole is basically the dipole moment. Okay, you have to remember few things here. So this is dipole moment P into E sine theta. Okay, now P is sine theta means what? This is a vector quantity, torque is a vector quantity, so as force, so is dipole moment. So torque is basically vector P cross E. Am I correct? Why so? Because there is a sine theta over here. Sine theta means cross product and cos theta means dot product, right? So these are all known fact. So from there we can calculate the torque acting on a dipole. Write any three properties of electric charges. Let's see. Obviously, additivity of charges are additive in nature. Quantization of charges, all the charges are integral multiple of smallest charge E. Conservation of charges, total charge in an isolated system is conserved. So these are the main three principles. So previously when I was to teach in the Brahmastra series, I used to give a little longer answer, but right now most students don't like longer answers. They like to remember only one word. So you guys are lazy. But if they ask you what do you mean by conservation of charges, you will not be able to answer if you don't know the answer, right? And that is why I say study ಸ್ವಲ್ಪ detail. So write three properties of electric field lines. Now again, properties of field lines are very, very important. It can come as a 2 marker, it can come as a 3 marker. So you have to at least remember 3 points. If they ask you 2 marker question, they will ask you write 2 properties. If it comes as a 3 marker question, they will ask you write 3 properties. Okay. So electric field lines may start from positive charge and end at a negative charge. Two electric field lines are never intersect each other. Electric field lines do not form any closed loops. Very common. You can mention that when you draw a tangent to a point in the electric field lines, that gives you the direction of electric field at that point. So there are other points. Stronger the electric field lines are closer. Weaker the electric field lines are far apart. So that is how we can add more points if you want. But at least these 3 points you have to remember. Now, question number 36. What is an equipotential surface? What will be the shape of equipotential surface corresponding to a single point charge? So any surface which has the same electric potential at every point is called an equipotential surface. The shape of the equipotential surface is spherical for a single point charge. So if the charge is single and point, then equipotential surface will be spherical in nature. It is a 3-dimensional symmetry. Even though I am drawing circles, it is actually 3-dimensional. So the shape will be 3D. In 3D, the shape will be spherical. Okay, let's move on. On what factors does the capacitance of a parallel plate capacitor depends? So let's see the answer. So we know that capacity of a capacitor is basically there is one more value, that is K. K is dielectric constant, right? So what are all the 3 factors? Basically it comes as a 2 marker question, but in case it comes as a 3 marker question, they might ask you write down the expression for capacitance of a capacitor and now write the factors on which the capacitance depends. Okay, so it directly proportional to the area of the capacitor plates, inversely proportional to the distance between the plates, and directly proportional to the dielectric constant kept between the medium. Okay, so it is directly proportional to the area. So C is proportional to area, C is proportional to 1 by D, and C is proportional to K. K is the dielectric medium kept between the plates. So this is a parallel plate capacitor. Okay, if you keep anything in between of dielectric medium, so that is the dielectric constant, right? Now let's move on to the next question. Write 2 properties of equipotential surface. Equipotential surface is very, very important. Okay, no work is done moving a test charge over an equipotential surface. This sometimes comes as an MCQ as well. What is the work done to moving a test charge in a equipotential surface? Okay, so electric field is always normal to the equipotential surface at every point. So electric field is always normal to the equipotential surface at each and every point. Okay. no two equipotential surface can intersect each other. Same as that of the electric field lines, same as that of the magnetic field lines, no two equipotential surface can intersect. Now obtain the expression for the effective capacitance of two capacitors connected in series. So we have two capacitors. They are connected in series. Now series means what is constant? In series combination, the current is constant or the charge is constant. Okay. In case of parallel combination, voltage is constant. Okay. So if Q charge is flowing in the circuit, okay, then the same charge will flow through all the components connected in series. That is the beauty of series combination. Suppose the capacitance of this one is C1, this one is C2. Obviously the diagram is compulsory. So what is the voltage V1 and what is the voltage V2? That is our target. Okay. So first we know that Q equals to CV. So for first capacitor Q is equal to C1 V1. So from there we can say that V1 is basically Q by C1. Similarly for the second capacitor we can say that V2 equals to Q by C2. Right. Now why we are finding V1 and V2? Because the supplied voltage capital V, okay, that should be equally divided in the circuit. Okay, from the conservation of energy this voltage should remain constant. Voltage you cannot destroy it. So V should be equals to V1 plus V2. Okay, that is Q by C1 plus Q by C2. Or Q gets common, you get 1 by C1 plus 1 by C2. Okay, this is the V. Now if you draw the equivalent circuit, now equivalent circuit is same for whatever combination you are using. Okay, it will only have one capacitor and one battery, nothing else. And the charge in the circuit will remain same. So this is C equivalent. So voltage is V. So in this case the entire voltage V is dropped across the equivalent capacitance. So for equivalent capacitance we can write that Q equals to C equivalent into V, or V equals to Q by CQ. So if we put that value over here, if we put that value of this V into this equation, we get C equivalent by Q divided by C equivalent, Q divided by C equivalent equals to Q bracket C1 plus C2. Okay, so from there we can say that this Q will cancel, and what you will get, Q1's a Q. So 1 by C equivalent is equal to 1 by C1 plus 1 by C2. This is the required expression for equivalent capacitance. Right? You have to show this derivation. The derivation means derive an expression means you cannot write the final equation. Okay, if you just write the final expression, you will get 0 marks. Okay, anda. Question number 40. Obtain the expression for the effective capacitance of two capacitors connected in parallel. This is the result is easy but slightly tricky, and in my opinion one of the derivation will come as a 3-marker question, highly probably. I cannot say will come, but highly probably. This is C1, this is C2, now this is V. So charge in this case say Q1, charge in this case will be Q2, but total charge is Q. Okay, so as I said that the charges, individual charges to do the individual capacitors will remain will be different, but the potential across each capacitor will be the same as the applied voltage V. That is the thing about parallel combination. So now again equivalent circuit, as I said, equivalent circuit will be same no matter series or parallel, same voltage. Okay, the charges, whatever total charge in the previous case, the same charge will flow. In this case the battery will remain same, C equivalent. Okay, so we have to find what is the C equivalent in this diagram. Now again, same formula, Q is equal to CV. So from first equation we get Q1 equals to CV. Voltage is same. Okay, capacitor is different, voltage is same, charge is different. So from equation 2 we get Q2 is equal to C2V. Okay, so what is the total charge? From the conservation of charge, we know that charges cannot be created or destroyed. So from there we can say that Q must be equals to Q1 plus Q2. Okay, so if you add these two values, so Q equals to C1V plus C2V, that is V common C1 plus C2. Now apply the same thing, same formula in the equivalent circuit as well. So how to do that? First we will apply the formula in one of the capacitor, next in the second capacitor, third in the equivalent capacitor. Only one formula, Q is equal to CV. So in this case, what is Q? Q itself is Q, V is V, only C is C equivalent. So Q equals to C equivalent into V. Okay, now what you have to do? You have to compare. This is 1, this is 2. In the previous case we compared the voltage, in this case we are comparing the charge. So if you compare them, C equivalent into V equals to V into C1 plus C2. Voltage cancels, so from here you get C equivalent equals to C1 plus C2. This is the easy derivation. Answer is simple. So in case of parallel combination, capacitors get added. Now give 3 results of electrostatics of conductors. This is also a new question, but maybe it will come in your exam, because I have seen this question appearing in multiple district exams as well. So let's see the answer. Inside a conductor, electrostatic field is 0. At the surface of a charged conductor, electrostatic field must be normal to the surface at every point. Okay. The interior of a conductor can have no excess charge in the static situation. Okay, so in the interior, inside of a conductor cannot have any extra charge when it is in static condition. That means no current is flowing. Static condition means no current is flowing. These are the basic 3 results of conductors. You can go and open your NCERT book and study a little bit more points, right? But 3 points are sufficient. Derive the relationship between electric field and electric potential due to a point charge. Okay, electric field and electric potential. So let's see. First of all, you have to draw this potential diagram. Okay, here as you can see, this is a point A, this is an equipotential A, and this is an equipotential B. The potential of equipotential A is V. The potential of equipotential B is V minus dV. You have to be careful. It is not V minus V plus. In your textbook there is a small correction given here. Electric field cannot be from lower to higher potential. Electric field always be from higher potential to lower potential. The direction is given in this direction. So electric field will always point from higher potential to lower potential. Very, very, very important. Okay, now how can we calculate the relationship between electric field and electric potential? First of all, what we will do, we will take a point test charge, say Q, and we will try to take it from A to B. Okay, at this point P, from A to B, point P. But it does not matter which point on B, because it is basically equipotential surface. So we will try to find the work done in 2 ways. Okay, if we calculate the work done in 2 ways, the work done is basically, electric field is a conservative field, so work done in whatever way you calculate should be the same. So first we will calculate. Let us consider a test charge Q is being taken from A to B. Okay, so what is the work done? So work done in terms of potential, what is the work done? Potential, in terms of potential, work done is charge into potential difference. So what is the potential difference means? Potential difference means final potential minus the initial potential. Okay, final potential is what? So we are coming over here, so final potential is V minus dV, and we started at A, that means initial potential is V. Okay, so it will be Q into minus dV. This is the first work done. Now second work done is basically depends on the force into displacement. Again work done is basically force into displacement. What is displacement here? Displacement is dl. Force into displacement dl is the work done. Now what is force? So here if the electric field is E, uniform electric field is E, then whenever you keep a charge over here, whenever you keep a charge Q over here, it will experience a force. Charge always experience a force in the electric field. What is that force? The force is basically Q into E. Okay, so force in an electric field is Q into E. So that means work done will be Q into E into dl. Okay, now this diagram is compulsory in this derivation. Okay, you can draw a simple diagram. You don't need to draw this dotted line. You can draw a simple diagram like this. Okay, this is a surface. This is another surface. Okay, you are going in this direction. So this is the electric field E. This is V. This is V minus dV. Okay, the distance is dl. This is A. This is B. Okay, this simple diagram is sufficient, but you have to draw a diagram to represent it. Okay, this kind of artistic diagram is not super necessary, but this is also understandable, right? So as long as it is understandable, that diagram will be acceptable. Now these two both work done should be equal. Therefore the same work done is here also, right? So what is the work done here? It was Q into minus dV. That should be equals to this same work done, QE into dl. Okay, or QQ cancels, you get E into dl equals to minus dV, or E equals to minus dV by dl. This is the very important derivation, okay, from this chapter. Small 3 marks derivation, not 5 marks derivation obviously, but it might come in your board exam. Let's move on to the question number 43. Write the expression for drift velocity in terms of current. Explain the terms used, and let's see the formula. So we know that current is basically NEA VD, or VD drift velocity is basically I by NEA. So here VD is drift velocity, I is current in the conductor, N is number of density of electrons, E is charge of an electron, A is area of cross section of the conductor. Okay. Now define drift velocity and mobility of free electrons in conductors, or define mobility, mention its SI unit. These both type of questions might come. Very important. So drift velocity is the average velocity with which the free electrons drift under the influence of an external electric field is called drift velocity. Obviously we know that I is equal to NEA VD, so VD equals to I by NEA. Okay, the mobility of free electron is defined as the drift velocity of electron per unit electric field applied. So mobility is basically drift velocity by unit electric field, so that is the drift mobility. Okay, so SI unit of electric mobility is meter square second inverse volt inverse, or meter square second inverse Newton inverse Coulomb. So whatever formula you are comfortable, or whatever you can remember, that you can remember. Okay, so this is very important question, especially the mobility and the unit. Okay, now next question, mention 2 limitations of Ohm's law. Another very common question. 2 limitation, 3 limitation, all types of limitation might come. Ohm's law is applicable only if all the physical conditions remain same. Ohm's law is not applicable at very low and at very high temperature. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. Okay, so these are the 3 pointers. Might come as a 3 marker question. Then you will say, sir, you only taught us for 2 marker, 1 extra point you have not given. So that's why I always give 1 extra point in all possible questions, because 2 marker questions can come as a 3 marker question, 3 marker question can come as a 2 marker question as well. Now again, give any 2 differences between current and current density. Now in this case it is slightly difficult for me to give 3 differences, but I will try to add 1 more difference if possible. So current is defined as the amount of flow of electric charge per unit time. Current density is the amount of current per unit area. Unit of current is A. Unit of current density is ampere per meter square. Okay, and you can write one more formula, that current is basically I equals to V by R. Okay, and here current density J equals to sigma E. Both are Ohm's law, but the forms are different. Okay, in case the same question asks as a 3 marker question, you should be prepared to write a third difference. So this is the third difference. And whenever you are seeing a difference question, that writing into a table is compulsory. Okay, so all the difference based questions should be written in a table only. Okay, you cannot write in paragraphs. That will not be considered well. Okay, some teachers might lenient and give you marks, but they can simply outright reject it as it is not a difference. Difference should always be written in a table format. Name the 2 factors on which the resistivity, very important, resistivity of a wire depends. Okay, so resistivity depends on material of the wire, temperature of the wire. So there is another question where it talks about resistance. Okay, resistance, you have to remember that resistance is different than resistivity. Okay, resistance is basically R equals to rho L by A. Here rho is resistivity, okay, and conductivity is 1 by rho. This is conductivity. Okay, so these are the very important terms. Now resistivity is dependent on material and temperature. Okay, whereas resistance depends on length, resistance inversely proportional to area. Okay, and also it depends on the material as well, but if the material is constant, resistance depends on directly proportional to length, inversely proportional to the area. But resistivity depends only on material and temperature. It does not depend on length, it does not depend on area. So these are the very common basic question which you might feel tricky to answer. Now, when does a current carrying conductor placed in an uniform magnetic field experience maximum force, minimum force? So it experiences maximum force when current is flowing perpendicular direction of the magnetic field, minimum force when the current flowing in the direction of the magnetic field. So as I said, it is low range force. Low range force is basically Q VB sin theta. Okay, if theta is 90 degrees, then force is maximum, and it is minimum if theta is 0 degree, that is in the same direction, right? Now let's move on. Derive an expression for angular frequency of revolution for a charged particle moving perpendicular to a uniform magnetic field. Okay, or obtain an expression for the radius of the circular path taken by a charged particle moving perpendicular to the uniform magnetic field. So both questions have almost same answers. Final result will be different. So first case we will find the radius. Radius is easier to find, so we will find the radius first. So what is the meaning of that? We have suppose a magnetic field like this, okay, and a charged particle is moving in a circle. You have to find the radius. This is radius, okay, velocity is v, charge of the particle is q, Okay, so whenever there is a circular motion, always remember that one force will always be there which has to be provided by someone. Okay, so what is that force? That force is called centripetal force. Centripetal force, and that is mv square by r. This is a force necessary for a rotational motion, and this force is provided by someone. Okay, this is not a force which comes into the action like tension. Okay, so this force has to be provided by someone so that the object can continue in the rotational motion. Now, who will provide the centripetal force? So this is a magnetic field. There is a charged particle rotating in the magnetic field. That means only other force which is acting here is basically QVB. Sin theta, sin 90 is 0. Sorry, sin 90 is 1, so that is why sin 90 we have ignored. So this force, centripetal force, has to be provided by the external Lorentz force. So basically we can say that mv square by r equals to QVB. Okay, both v's are same, so one of the v's will cancel. Now, as I said, we are trying to find r in this case, so just do the cross multiplication. You will get r equals to mv divided by qb. Okay, this is the first expression. Okay, so this is very easy. So if they ask you find the radius of a rotational charged particle moving in a circular motion in a magnetic field, you can find it, right? So this is the easier derivation. Now if they ask you the same question with frequency, now the derivation is slightly tricky. Why so? Because first of all, to find frequency you have to find angular velocity first. So what is angular velocity? Angular velocity is angular velocity is v equals to r omega. So v equals to r omega, that you have to substitute in this place of v. Then from there you have to calculate omega. Let's put that. We know first PU, if you remember, v equals to r omega in the rotational motion. So r equals to, don't use this equation, you can put v in this equation itself. Okay, that will be slightly easier. Okay, so this was mv by r, right? So m r omega by r equals to qb. One of the v's cancel, right? So qb is there. Now this r cancel. So we are using this equation. Okay, we are using this equation. So r cancel. So m omega equals to qb, or omega equals to qb by m. Now this is not the answer yet. This is the angular velocity. Now frequency is basically 2 pi f. Omega equals to 2 pi f. The same formula we used in the chapter alternating current as well, right? So 2 pi f equals to qb by m, or f equals to qb by 2 pi into m. Okay, so this is the final result. So frequency is basically given by qb by 2 pi m. Okay, maybe you are not visible here. So this is clearly the answer. So both the derivations are important. Okay, one of the derivations, any one of the derivation might come. So both you have to practice. Okay, this one is easier. As you can see, this is directly the result. This one is slightly trickier, where you have to substitute v is equal to r omega and then cancel it and then solve it to find omega. From there again you have to substitute one more step, 2 pi f, to find the final result, right? Now, what is Lorentz force? Write the expression and explain the term. So Lorentz force is when a charged particle moving in a electric and magnetic field, it experiences a force. Okay, that force is given by force is equal to Q into E plus V cross B. This is the expression for Lorentz force. Here E is Q is charge, E is electric field, okay, V is velocity, okay, and B is magnetic field. So first you have to write what is Lorentz force. So when a charge particle moving in a region of electric and magnetic field it experiences a force called Lorentz, I think LOR, Lorentz force. Okay, so first you have to write the definition, then you can write the expression. Okay, so both you have to write to get full marks for this question. Okay, 2 marker it can come, 3 marker it can come, both are possible. Now, how can a galvanometer be converted into a voltmeter? Explain with diagram. So again, this is a very common question. Galvanometer to voltmeter, galvanometer to ammeter, both type of conversions are very common. Let's see. A voltmeter should have a very high resistance as it is connected in parallel in the circuit. A galvanometer is converted into a voltmeter by connecting a suitable high resistance in series with it. This way the overall resistance of the voltmeter remains high. Okay, so this is the very important, and then you have to show this diagram as well. Mathematical expressions are not required because that is not part of your NCERT book, but the explanation should be crisp and clear. So this is the galvanometer with, this is the resistance of the galvanometer, this is the internal resistance of the galvanometer. This is optional if you show G itself has the meaning of resistance of the galvanometer. This is the external resistance that you applied. This is the internal resistance, this is the external resistance. Okay, now so basically what is the meaning? You have to convert it into a voltmeter, you have to apply high resistance in series. Why? Because the galvanometer is connected in parallel. Okay, if you connect a small resistance in parallel, then all the current will pass through the smaller resistance, no current will pass through the circuit in this, right? But our objective is to measure voltage. That means only way to measure voltage is that the small amount of current should pass through the original galvanometer, right? So to do that, we have to apply an external high value resistance so that very small amount current pass through it. Okay, now how can a galvanometer be converted into an ammeter? Okay, once there was this same question was asked in a class exam, and the student answered that by writing ammeter level on a galvanometer. Right, nice, no? So only just change the level of galvanometer into ammeter, you will get you will convert it into a ammeter. Such a creative answer. But no, to convert it into an ammeter you should have a very low resistance as it is connected in series in the circuit. So if you connected a high resistance in the circuit, what happens? The overall balance is basically disturbed. So our objective is do not disturb the overall balance. So whenever we are considering ammeter, which is measuring current, which is parallel to the which is obviously in the series in the circuit, right? That is why ammeters are connected in series so that it can measure the current, and voltmeters are connected in parallel to measure the voltage. If you remember series and parallel connection, I gave you the example. In parallel connection, voltage remains constant. In series connection, current remains constant. So if you want to measure the current, it has to be connected in series. But we don't want to affect the original circuit, so we want ammeter to have as low as resistance as possible. So that is why we always connect a small value resistance, that is called shunt, in parallel to the ammeter. So this is the galvanometer. This is the original resistance of the galvanometer. This is the shunt resistance which is connected in parallel. Okay, this is achieved by connecting a suitable low resistance S in parallel called shunt with the galvanometer. This way the overall resistance of the ammeter remains low and the galvanometer is converted into an ammeter. Okay, now let's see. State and explain Biot-Savart's law, write its vector form. So this is the Biot-Savart's law. So as you can see, this diagram has to be drawn. So magnitude of magnetic field at any point P due to the current element dl is directly proportional to the strength of the current I, directly proportional to the length of the current element dl, directly proportional to the sine of the angle between the current element and the line joining the given point charges, given point and midpoint of the current element. And so this is the angle theta, obviously midpoint of dl and the point joining the point, okay, inversely proportional to the square of the distance between the current element and the point. Now they have asked you to write the vector form. Okay, vector form is means dB vector equals to mu naught by 4 pi. Be very very careful. Okay, I R cross dl by r square. Okay, so this is the vector form. It is not I cross dl. Okay, it will be the r cap cross dl. So that is the direction. So you have to be very very careful about the vector direction. Okay, now give the principle of AC generator. Why is a current induced in an AC generator called alternating current? Mention the expression for induced EMF in it. Let's see. So principle, an AC generator converts mechanical energy into electrical energy by changing the flux linked with a rotating coil. So you can draw the diagram as well. So as this coil rotates in the magnetic field, okay, the flux linked with this coil changes rapidly. Okay, it changes from maximum to minimum, and because of that it induces a current into it. That is the principle of AC generator. Okay, the direction of current produced in an AC generator changes periodically, and therefore the current is called alternating current AC. Okay, now let's see. So because as it is rotating, what happens? As it is rotating, so from 0 to maximum, it gives you a current. From maximum to 0, it gives a current, but in the opposite direction. That is why the current direction of the current fluctuates, and that is why it is called AC current. Okay. Write 3 differences between diamagnetic, paramagnetic or ferromagnetic materials. Very 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 important. So this is a combined table, and the notes for this will be available in our channel, in our WhatsApp channel. So don't forget to join our WhatsApp channel if you have not yet joined, right? So this is a consolidated table. If you want to take a snap, you can take a snap and remember it. Okay, so so first property is magnetic behavior. Those are diamagnetic substances are weakly repelled by magnetic field. Paramagnetic substances are weakly attracted by magnetic field, whereas ferromagnetic substances are strongly attracted by magnetic field. Now let's consider magnetic susceptibility. Have a small negative magnetic susceptibility. Okay, have a small positive magnetic susceptibility. Have a large positive magnetic susceptibility. Okay. Now effect in a magnetic field: induces magnetic moment at the opposite direction of the applied field, induces a magnetic moment in the same direction as the applied field, induces a strong magnetic moment in the same direction of the applied field. So this is the basic 3 differences. Any combination can come: diamagnetic, paramagnetic, paramagnetic, ferromagnetic, ferromagnetic, diamagnetic. So all 3 difference table is done in only through this single table. Okay. So this is basically worth of 3 questions. Write any three properties of magnetic field lines. Another easy question, but very, very important and most expected, one of the most expected questions. The magnetic field lines from continuous closed loop, very, very important. Okay, electric field lines were not closed, they are open, but magnetic field lines are closed loop. The tangent to the field at a given point represents the direction of the net magnetic field at that point. So this is also common, this is common between electric field and magnetic field. Larger the number of field lines crossing per unit area, stronger the magnetic field, magnitude of the magnetic field at field B. This is also common. Okay, the magnetic field lines do not intersect. This is also common. So these 3 points are common in electric and magnetic field, except the first point. Okay, in case of electric field, they never make a closed loop, whereas in magnetic field they always produce closed loop. Okay. State and explain Gauss law in magnetism. This is Gauss law in magnetism. Gauss law of electricity is also important. We will see that when we are discussing a long answer type question. I have included that in the part of the long answer type question. I don't think that individually also, if this comes as a 2-marker question, you can write the same answer. Answer will be same, right? But Gauss law of magnetism is not there in that 5-marker question, so you have to cover it in this part. Let's see. Gauss law for magnetism is the net magnetic flux through any closed surface is 0. So B dot ds equals to 0. Physical significance: magnetic monopoles do not exist, that is magnetic field lines are always formed closed loop. Okay, so this is the basic physical significance of the Gauss law of magnetism. Also you can say that total number of lines entering into a surface is equals to total number of lines exiting the surface, that is magnetic monopoles cannot exist. So magnetic monopole do not exist is the major point of the Gauss law. But why so? Because the number of field lines through a closed surface will be always 0. Total number of field lines in a closed surface will always be 0. Define magnetization of a sample. How it is related to magnetic intensity. Another important question. Magnetization of a sample is measure of the magnetic moment per unit volume of the material. So magnetization is basically net magnetic moment divided by volume. So what is the net magnetic moment of entire material divided by its volume is the magnetization per unit volume. That is called magnetization. Okay, and magnetic intensity, which is H, that is the applied external field. Okay, that gives you M equals to chi into H. Here chi is called the magnetic susceptibility. Okay, from here we define magnetic susceptibility. Okay, how susceptible a material is. So whatever the field is there inside the material, based on that how quickly it is magnetized. Okay, that is the basic meaning of it. Okay. State Faraday's law and Lenz's law of electromagnetic induction. Very common question. So the time rate of change of magnetic flux through a circuit induces EMF in it. Okay, and so basically it says that induced EMF is basically proportional to the change of magnetic flux through it, right? The polarity of induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux that produces it. Okay, so that means epsilon equals to minus d phi b by dt. Okay, now let's move on. Mention any two factors on which the self-inductance depends. Okay, the equation of self-inductance is L equals to mu naught n square A into L. So self-inductance is directly proportional to the square of the number of turns per unit length. So this is turns per unit length. Very, very careful. This is not the total number of turns. Self-inductance is directly proportional to the cross-sectional area A of the solenoid, and self-inductance is directly proportional to the length of the coil. So it is directly proportional to the area, directly proportional to the square of the number of turns, and it is proportional to L. In fact, if you insert, so here it is a AR coil, that means the inside there is only air, but if you insert a material of say relative permeability mu, or relative permeability mu r, then that same formula becomes mu naught mu r, okay, n square A into L. Okay, so it depends on the whatever the material that is there in the inside the coil. Okay, derive the expression for motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. Another very common and most asked, most repeated question is this one. So where you will have the you have to draw this diagram, and this cross are also compulsory. This cross represents a magnetic field into the page of the paper, right? So this cross is nothing but magnetic field into the page of the paper. Okay, now this diagram is compulsory. Now what you have to start with, first of all you have to start with the magnetic flask. So magnetic flask is basically magnetic field into area. That is the definition of magnetic flask. Now what is magnetic field is B given here, and the area is basically the area of this rectangle. What is the area of this rectangle? Length into breadth, right? So we can say that magnetic flask is B into L into X. Right, now from Faraday's law, the induced EMF, the magnitude of induced EMF is rate of change of magnetic flux, that is d phi b dB by dx, or sorry dB by dt, time rate of change, right? So now what you can do, you can just simply differentiate this ddt of B L X. Now magnetic field is constant coming out of the differentiation. The length, this length is constant, it is coming out of the differentiation. But if you see that this x is not constant because it is moving with velocity in this direction, so that means it is changing. The x is changing with time. So x is changing with time means what is the time rate of change of x? Time rate of change of x is basically its velocity. So it will be B L into V. So induced EMF is B L into V. This is the expression for motional EMF, as simple as that. Okay. Explain briefly the coil magnet experiment to demonstrate the phenomena of the electromagnetic induction. This is also a very common question. When the magnet approaches the coil, so first of all you have to draw this diagram like this. Okay, so here we have a coil and this magnet is moving towards the coil and it is coming out of the coil. Okay, so when the magnet approaches the coil, the galvanometer needle deflects, indicating that a current is induced. When the magnet is pulled away from the needle, now the needle deflects in the opposite direction, showing that the current reverses. No current is induced when the magnet is stationary relative to the coil. So these are the 3 points that is you are observing during the experiment. So first you are taking the magnet, you see a deflection in the galvanometer. Okay, when you are taking the magnet away, again a deflection is happening, but if the deflection was previously in this direction, now it will be in the opposite direction. Okay, so when you are taking the magnet, the deflection is happening some direction. When you are pulling it away, the deflection is happening in the opposite direction. Now if the magnet is stationary, it is not moving, then no deflection is happening at all. Okay, now you have to write a brief conclusion about this. The current is induced in the coil when the magnetic flux through the coil changes. Okay, so taking it forward and backward means magnetic flux linked with the coil is changing. Okay, this confirms Faraday's law of induction, and the direction of the current follows the Lenz's law, opposing the change in the magnetic flux. This is a very simple, easy conclusion. So when you are changing the flux, in EMF is induced, that is Faraday's law, and the direction, because when you are going forward and backward, the direction changes, that means it is following the Lenz's law as well. So both is very important. It is very important, very expected question, even though little theoretical, but expected questions are always easy to answer, right? So I hope you, if the question comes in your final exam, you will be ready and answer this question. Now mention 2 or 3 uses or applications of Polaroids. All are common. So let's see. Polaroids are used to control the intensity in sunglasses, window panes, etc. Polaroids are also used in photographic cameras and 3D movie cameras. They are used in 3D movie glasses as well. So this is a 3D movie camera, this is 3D movie glass. So 3D movies are recorded using Polaroids and 3D movies are watched using 3D glasses. So both are different, okay, both are different points. So very careful. Polaroids means if you visit a 3D movie theater, whatever movies you are watching, if you are watching a glass, that glass is basically a Polaroid, except if they are red and blue old fashioned glasses, okay, that you see in a village fair. Now 74, mention Einstein's photoelectric equation and explain the symbols. Okay, we are still in the 2-3 mark category. So this is the Einstein's photoelectric equation. H nu equals to 5 plus half mv square. Okay, here H is Planck's constant, 6.6 into 10 to the power minus 34 joule second. Okay, small correction over here, this will be joule second. And nu is the frequency of incident light. Okay, phi is the work function of the metal, m is the mass of electron, 9.11. Now these are optional, you don't need to write the values, but you have to at least write what is the meaning of it. V is the velocity of the ejected electron. Okay, write 3 features or properties of nuclear force. Another very important, exciting question. The nuclear force is much stronger than the Coulomb force acting between charges on the gravitational force between them masses. So nuclear force is obviously the strongest force. Okay. The nuclear force between two nucleons falls rapidly to zero as their distance is more than a few femtometers. Okay, the nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on the electric charge. So nuclear force is independent of the charge. Okay. Now write 3 limitations of Bohr's atomic model. Another very important question. The Bohr model is applicable to hydrogenic atoms. It cannot be extended even to mere 2 electron atoms such as helium. Okay, so it is a hydrogenic atom, means obviously hydrogen is one of the hydrogen atom. Other than that, helium plus 1 can be considered as a hydrogenic atom, and lithium plus 2 can also be considered as hydrogenic atom. But if you consider normal helium, then it is not a hydrogenic atom. Very careful. Okay, it is not extended to helium, but hydrogenic atom means if you are considering plus 1 or lithium plus 2, you can still consider them to be a hydrogenic atom. While Bohr's model correctly predicts the frequencies of the light emitted by the hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies of the spectrum. So if you observe any spectrum of hydrogenic atoms, okay, according to Bohr, all the lines appearing in the spectrum should be equally bright. But when we observe it carefully, we see that some of them are very bright, whereas some of them are very weak. Okay, not even clearly visible. You have to use a lot of detail to find that line. So why it is so? Not clear. The model does not explain the fine structure of splitting of spectral lines. So if you apply electric field or magnetic field, okay, this one single line sometimes split into 3. Now why that is happening? Okay, why one line is splitting into 3 lines, that was not been able to explain by the Bohr's model as well. So one of them is Zeeman effect, one of them is Stark effect. You do not need to remember, but you have to mention that under the influence of magnetic and electric field, the fine structure is fine structure splitting is not been able to explain by the Bohr. Okay, that is the main thing. Now let's look into the question number 77. How is the total energy of an electron revolving in an orbit of hydrogen atom related to the principal quantum number of the orbit? What is the significance of the negative sign of the expression for the total energy of the electron in a hydrogen atom? So it's an easy question. Let's see the answer. So the formula is En equals to minus 13.6 divided by n square eV. It will be in EV. Okay, the negative sign indicates that the electron is bound to the nucleus. To free the electron, we need to provide equal amount of energy to the electron. That is the basic significance of the negative sign. Okay, now let's move on. What are coherent sources of light? Give one example. So coherent sources of light are light sources that emit light waves with the same frequency, wavelength and phase, or have a constant phase difference. Example is obviously laser light. Now let's move on. State Huygens principle in wave theory of light. So this question can come as a part of your 5-marker question or as an individual 2 or 3-marker question. So in both cases, if they ask you 3-marker question, the diagram is compulsory. If they ask you only 2-marker question, you can leave it in the statement. Okay, Huygens principle states that every point on a wavefront acts as a source of spherical wavelets. The sum of these wavelets form the new wavefront. Okay, so these are called secondary wavelets or spherical wavelets. So each point on the primary wavefront, these are the points on the primary wavefront, they all behave like a secondary source and they emit light in the all possible direction. So, and if you take the tangent, common tangent across them, you get the second primary wavefront. This is another primary. The black lines are the primary wavefront and these blue lines are the secondary wavelets. Okay. Now, give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. So, photoelectric equation we have already written once, so that is why we are just going to give the explanation. Now, combining these two, they can ask you a 5-marker question as well. Along with this, they might ask what is threshold frequency, what is work function, like that. Okay, so this is the part of the question. So be careful, this can come as a 5-marker question as well. Einstein suggested that each photon of light has energy proportional to its frequency nu, given by E equals to h nu, where h is the Planck's constant. When light shines on a metal surface, photons transfer their energy to the electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron, right? So h nu equals to phi plus half mv square. This is the Einstein's equation. We already learned that, right? Now let's move on. How can a semiconductor diode be forward biased? What happens to the width of the depletion region when forward bias voltage is increased? Let's see. A semiconductor diode is forward biased when you connect the positive terminal of a power source like a battery to the P side of the diode and the negative side of the terminal to the N side of the battery. This setup helps to overcome the potential barrier created by the depletion region and allows the current to flow through the diode. Right, so we have a diode, we have a P side, we have a N side. So if you connect the positive of the battery with the P side and negative side of the battery to the N side, it helps to reduce the depletion region and the diode starts conducting. Okay, and as you increase the forward bias, so if you increase the forward bias voltage, okay, the depletion region becomes narrower and slowly disappears. So this depletion region, whatever is between the P and N type, it becomes thinner and slowly it disappears. There is no depletion region left. It just behaves like a normal conductor, right? State. Now we are into the 5-marker territory. Now we will be solving some 5-marker derivations and few numericals. Okay. So state Gauss law of electrostatics. Derive an expression for the electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss law. Very common and most asked question. Okay, statement: the total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by that surface. So phi equals to E dot ds, that is equals to Q by epsilon naught, right? So this is the explanation also for Gauss's law. So they might ask you state and explain Gauss's law as a 2-marker question as well. So you have to answer this question like this. Now Let's look do the derivation as we have done in a many times before. So we have a very long, infinitely long straight wire which is go this side as well and this side as well. Okay, you cannot draw infinity, so you have to draw a whatever you can do. Use scale and pencil or pen to draw the diagram. If you are drawing using pen, then be careful, you have to practice the diagram 2-3 times. If you are using pencil, try to use HB pencil, which is little bit thicker, right? Now what you have to do, if you have followed my derivation series, I have done this derivation, but obviously we will not do the same derivations again and again. We will do some other derivations as well, but this is a very important derivation, so that is why we are doing it again. This is R. Okay, the charge per unit length is lambda, the length of the cylinder is L. Okay, so there is no magnetic field, there is no electric field in this direction. All electric field are in this direction and in this direction, so electric field is in this direction, right? So let us consider a cylindrical Gaussian surface. Let us consider a cylindrical Gaussian surface of radius R and a cylindrical Gaussian surface of radius R and length L, right? So from Gauss law we can say that close integral E dot ds equals to Q enclosed by epsilon naught. Now what is Q enclosed here? Q enclosed is total length into charge per unit length, that is Q enclosed. So from there we can say that now electric field is constant on the surface of the cylinder, so that will come out and it is cylindrical symmetry. So E into ds equals to L lambda divided by epsilon naught. Now so E into, what is ds here? Ds is the curved area. Curved area, I told you, curved area of a cylinder is 2 pi L RL. Okay, 2 pi RL is the curved area of the curved surface. So 2 pi RL is equal to L lambda by epsilon naught. So L cancels. So you get E equals to lambda by 2 pi R epsilon naught, or if you organize it a little bit, it will be 2 pi epsilon naught lambda by R. Okay, so this is the final expression of the electric field. So if you do this derivation, you get 3 marks. Okay, now let's move on. Derive an expression for the electric field at a point outside a charged spherical shell using Gauss law. Again, very important question. Also this question generally don't come alone. There will be a statement of Gauss's law, state Gauss's law, and then they will ask this question. So statement of the Gauss's law will be same. So charged shell means it's like a cover of the egg. Okay, so there is some charges. Now remember that inside a charged shell the electric field is 0. Okay, inside the shell charge electric field is 0. Electric field is 0 inside, only electric field will be there on the outside. So now what is the electric field on the outside? Say at a distance r greater than the radius r. Very easy derivation. This is a very easy derivation. Okay, r greater than r. Okay, that is the only thing that you need to consider. Now again you have to construct a Gaussian surface which is spherical in nature. Okay, you can write that let us consider a spherical Gaussian surface of radius small r greater than capital R. Okay, now the total charge on the surface, total charge, this is easy because there is no charge density. Total charge on the shell, say Q. Okay, then how to do that? E dot ds equals to charge enclosed. charge enclosed. So if you consider this is your Gaussian surface, okay, that entire charge, whatever is on the shell, the entire charge is enclosed by this Gaussian surface. So what is the formula? It will be same as Q by epsilon naught. That entire charge will be here, because your Gaussian surface is this. This is not the Gaussian surface. This is just the shell. Okay, your Gaussian surface that you have imagined is much bigger than that. Unfortunately, I cannot draw it. My original shell is little bigger, so my Gaussian surface has to be bigger than that. Let me try it so that you don't get confused. So what I can do, I can reduce the size of the Gaussian surface so that you don't get confused. So this is the shell. Okay, this is my Gaussian surface. This one is my Gaussian surface, the outer one. Okay, this is the R greater than R. Okay, this is my Gaussian surface. Okay, so in this case, this Gaussian surface encloses the entire charge on the shell. That is why it is Q by epsilon naught. Okay, so again spherical symmetry is there, so you can take that outside. So E into ds equals to Q by epsilon naught. Now what is ds here? ds is a sphere of radius r. So sphere of radius r means the surface area is 4 pi r square. So E into 4 pi r square equals to Q by epsilon naught, or it will be E equals to 1 by 4 pi epsilon naught Q by r square. So this is the formula. Okay, this is the formula. Very easy. Again, it will be part of the question with Gauss's law in a statement. Okay, so this is a very, very common, most asked question, one of the most favorite question of the teachers from the previous years. Right now, define electrostatic potential due to a point charge and arrive at the expression for the electrostatic potential at a point due to a point source charge. So what is the definition of electrostatic potential? Work done to move a unit positive test charge from infinity to a point in the electric field is the potential at that point. As simple as that. So easy definition. So whatever work you are doing to move a unit positive charge from infinity to that point is the potential. Now I have done it multiple times. Right now I will be doing it a little bit simpler way so that everyone can do it. So first of all, as I said, you are not at infinity. This is your point of final point, destination. Okay, and you started at infinity, the charge started at infinity. Okay, but you cannot go there. So what we will do, we will take some intermediate point which we do not know the exact value, but we can imagine it. Okay, so this is the distance x, and in this case we will consider a unit positive charge itself. So unit positive charge itself, so that at the end the division part is removed. Okay, so here we will be solving it in an easier way. Okay, so how to do that? First of all, this charge is +1 and we are bringing it from infinity. So now it is at some point in intermediate point, say A. So at this point A, what is the electric force acting on this? So electric force, we know that is the charge into electric field. Okay, charge into electric field. Suppose the electric field at this point is E. Obviously electric field is not constant, it is changing. So electric field at this point is E. Then the force is basically unit positive charge into E. Okay, so that is the expression. Now what is E here? Electric field E is basically given by K Q, capital Q here, KQ by distance square. So distance in this case is x. So the electric field at this point will be KQ by x square. right? So the force will be kq by x square. So this is the force. Now if you move it by a very small distance from here to here, at this range we can say that electric field is almost constant. Okay, now why we need to do this? Because electric field is different at each and every point. That is why we have to take the help of integration. Okay, so but if we move it by a very small amount dx such that this electric field is almost constant during that distance, then what is the work done? So work done in that moving of the small displacement is basically given by one more thing. This is the force acting on the charge. So we have to first apply some external force. We have to apply some external force to move the charge. Okay, and that external force should be equals to opposite of the opposite to the field. Okay, this is the force due to the field. This is the external force. So field will try to take it away. We are trying to bring it in this point. So that is why the direction is opposite. That means you have to apply an external force which is equal but in opposite direction. So the applied force should be kq by x square minus kq by x square. Okay, this is very important point to remember. This point student often forget. So what is the work done? So work done is basically applied external force into the displacement, that is dx. Okay, so what is applied external force? Applied external force is minus kq by x square into dx, right? So what is the total work done? So total work done is basically integration of dw, right? So that will be minus kq outside dx by x square, and the limit will be, obviously we are starting at infinity and we are ending at our final destination, that is r. So infinity to r, so integration will be definitely infinity to r. Okay, so now let's complete the integration. So from here, after this it goes here. Okay, so integration of so w equals to minus kq, okay, integration minus 1 by x infinity to r. Now this minus sign can come out and minus it will become plus. So kq 1 upon r minus 1 upon infinity. Okay, now 1 upon r will remain, 1 upon infinity is 0, so it will be kq by r. Now definition of potential is basically work done by unit positive charge. So potential is equals to work done, that is, now we have to put it some formal rest. So instead of k you have to write 4 pi epsilon naught q by r. So till now he was at home, now he is going to the marriage ceremony. So marriage ceremony is, obviously you have to put him some clothes. The clothes is 1 by 4 pi epsilon naught. Okay, so this is also very important derivation. But my mind is saying that this year derivation will come from the chapter electrostatic forces. Okay, potential came last year, so maybe they will not ask you potential related derivations, but you cannot say that with confidence. There are 3 different blueprints, all the blueprints are different, so that predictability is gone for this year. Okay, this year question paper might be super difficult, but don't worry about it. You can answer if you check all the derivations, all the videos that I have been doing so far. Okay, now derive the expression for electric field at a point on the equatorial plane of an electric dipole. So electric field on the equatorial plane, axial one I have already done, but in my axial one, equatorial, both I have done, but in I feel that this might be very important this year. Okay, so I am only doing the equatorial plane in this video. If you want to check the other one I have done in the all derivations video, marathon video, which is I think almost 1.5 hour, 1 hour 40 minutes long, you can check that out, where I have done the equatorial plane on the axis of the dipole as well. Okay, or if you want, you can mention that in the document shared with you in our WhatsApp channel. You can mention that, sir, I have some confusion regarding that. I will be doing that live whenever we are doing the live session tomorrow. Time will be informed to you previous, obviously through our WhatsApp channel and our channel feed as well. So obviously I forgot to tell you that tomorrow I'll be coming live with all of your doubts. Also, there will be a recorded video of top 50 PYQs, which is mostly the similar questions with a little bit more focus on previous year numerical questions. So that I will be trying to cover tomorrow as well. Okay, so now let's move on to the expression for the electric field at a point on the equatorial plane of the electric dipole. Okay, so this is a plus charge, this is a minus charge. Okay, what you have to do, you have to find the electric field on the equatorial plane. So this is the equatorial plane, so you have to join them. The distance, say this distance, say r. Okay, and as we know that dipole can be we always consider the distance between the dipole is 2a, so that we can equally divide it. Now this is the equatorial plane, so this angle theta means this angle will also be theta. Okay, and this electric field will be in this direction, repulsion, and this electric field will be in this direction, attraction. Now if you take the component of them, okay, the components along y direction will cancel, only electric field on the x direction will remain. And because they both are in the same direction, both the electric fields are in the same direction, say this distance is x. Okay, charges are of equal magnitude, distance are same, so the electric field due to positive and negative, both electric fields will be same in magnitude. Okay, that means first of all you can write that E plus equals to E minus equals to E. Magnitude wise, okay, direction will be different, and as I said, in case of electric field, the the sign of the charges are only relevant to find the direction. Okay, while applying the electric field, you do not need to put the sign of the charge while calculating electric field. So E is basically k q by x square. Now what is the value of this x? X is basically square root of r square plus a square, Pythagoras theorem, r square plus a square, right? So what we can write is that this is basically kq divided by r square plus a square. Okay, square root whole square, so square root cancels, so only thing that is left is E equals to kq by r square plus a square. Now as you see that here we have only x component, so both of them will have the same E. So what is the Ex? Ex is basically if this angle is theta, this angle is theta, this angle will be also theta. Okay, and again this angle is theta means this will be also theta, alternate angle, right? Both angles will be theta. So now E cos theta plus E cos theta, so it will be 2E cos theta. Okay, so 2E cos theta. Now what we have to do, we have to put the values kq by r square plus a square into cos theta. Cos theta is, now what is cos theta? To find cos theta, what we will do, we will find this triangle. Okay, we will just try to find the cos theta from this triangle. Cos theta is base by hypotenuse, so for this angle, this is the base side and this is hypotenuse. Hypotenuse is common, so base is a, hypotenuse is x. X means square root of r square plus a square. Okay, so this is the hypotenuse, so this is the cos theta. So 2E cos theta is very simple. Now only thing is left is to put the value of k 1 by 4 pi epsilon naught and then q into 2a and then r square plus a square. Here it is to the power 1, here it is to the power half, so if you add 1 plus half you get 3 by 2, so here will be power 3 by 2. Okay, now you have to take one approximation, that is r is very greater than a, because we always assume that dipole is basically point charges separated by a small distance. The distance A is very small, so that is why all the other distances generally are very large. So the electric field is basically 1 by 4 pi epsilon naught. Now what is this Q into 2A? Q into 2A is the dipole moment, so it will be P divided by R square to the power 3 by 2, that is these two cancel, so you get 1 by 4 pi epsilon naught P by R cube. Right, now this is not done. Dipole moment is a vector quantity, so as electric field. Now the dipole moment points from negative to positive, so this is the direction of dipole moment, whereas electric field, as you can see, it is in the opposite direction. So in vectorial form, Ex is basically minus 1 by 4 pi epsilon naught P by R cube. This negative sign comes because electric field and dipole moment are in the opposite direction. Okay, so this is the final expression. You have to reach here. Okay, up to reaching here they might deduct 1 mark, so you have to show that electric field is basically negative of the dipole moment because the direction of electric field and the dipole moment are in the opposite direction. Okay, and also at this stage you have to mention that P is equals to 2QA. Okay, this is very important to mention. Okay, if you don't mention, then they will think you have copied it from your friend and they will deduct 1 mark as well. Okay, so whenever you are doing some substitution, like you write in mathematics, you have to write in physics as well. Okay, now obtain an expression for potential energy of an electric dipole placed in an uniform electric field. Define the electric energy density of charged capacitor. How is the energy density related to the electric field between the plates of the capacitor? So second part we will see later. First we will answer the first part, that is when an electric dipole is placed in an electric field. Obviously we have learned in the previous 2 marker section that how can we calculate the torque on it, right? So angle was theta. The same diagram we have to draw. So this is plus charge, this is minus charge. Okay, so what was the torque? Torque was P cross E. That is, if you remove the vector sign, it will be PE sin theta. Okay, so it will be PE sin theta. Now if it was a force, if torque was a force, then what was the work done? If you remember work done, and also you have to remember that work done and potential are same. Potential energy, basically work done and potential energy are same. You have to go back to work energy principle, which only talks about kinetic energy, but if the field is conservative, then potential energy, total potential energy is basically is equals to the work done. Okay, so work done is basically force into displacement, right? Force into displacement. Here force is a linear quantity and displacement is also a linear quantity, right? So if you want to find the work done in rotational motion, so small work done, Salpa work done, then what you have to do, you have to use the equivalent displacement. In case of rotational motion, the equivalent displacement is theta. So here the work done will be tau into d theta. Okay, now put the value of tau, PE sin theta d theta. Now here P is constant, dipole moment of the dipole, negative to positive is constant. The electric field given is constant. Only thing that is changing is sin theta. How you are changing the sin theta? Based on that the potential energy will change. So the work done is basically PE. The total work done is basically integration of sin theta d theta. Okay, now the limit of the integration is very interesting. So we will start the integration at pi by 2 and then we will reach at theta. Okay, so for potential, pi by 2 is considered to be the zero potential. Okay, so the work done is basically then given by PE. What is the integration of sin theta? Integration of sin theta is minus cos theta. Why so? Because differentiation of cos theta is minus sin theta, so integration of sin theta is minus cos theta, and its limit is pi by 2 to theta. Okay, so you will get minus PE cos theta, because cos pi by 2 is 0 and negative sign will come out, so negative will be there. So this is the work done. Now by the definition of energy is equals to work done, so energy is basically minus PE cos theta. Now remember that this derivation can come as a it can come as a 3 marker derivation as well individually, okay, without the part 2. Part 2 is given here because this is asked as a 5 marker question. So let's see the part 2 answer here as well. So the energy density of a charged capacitor is the energy stored per unit volume of the electric field between the plates. So energy density U is basically total energy stored, that is capital U, divided by unit volume. Okay, this is the formula. Okay, now the relationship between electric field and the energy density is small u equals to half epsilon naught E square. Now if you remember that total energy stored is half C V square, here V is voltage, V is potential actually. Okay, this is the formula for total energy stored. Here this V is volume. So don't get confused, here this V is volume and here this V is potential between the plates, potential difference between the plates. Okay, so this V and this V are different if you divide this quantity with the volume of the capacitor, then you get this energy density. This can be proven but that maybe is not required for your PU board, so I am not going to do the derivation here. Okay, derive an expression for effective EMF and effective internal resistances of two cells of different EMFs and internal resistances connected in series. This is very common question. So here again we will take two cells. Let me start on this side of the board this time. So we have two cells, only two cells are there, so we will not use more than two cells. So here we have a epsilon 1 R1, epsilon 2 R2 and the equivalent diagram. So suppose the current in the circuit is I, the external resistance is R. Okay, now in case of equivalent, now remember that in series combination the current is constant, so current will be our hero in this case. Okay, if it is parallel combination, then voltage is constant, so voltage would be our hero. Okay, so first what we have to do, we have to somehow find what is this relationship, internal relationship. We will apply Kirchhoff's law. Okay, so if I current is coming here, then the same current I will pass through the resistance, same current I will come back here, and the same current I will be coming through this battery as well. So entire circuit, the current I will be remaining constant. So we will apply Kirchhoff's voltage law for the first circuit. So applying KVL in circuit number 1. So this is the circuit number 1, this is the equivalent circuit, circuit number 2. KVL in circuit 1. Okay, how to apply KVL? So as I said, always current into resistance. Current into resistance. Now you have to move with the direction of your pen. If you are moving in the direction of the current, then everything will be positive. So again, when you reached at R2, we are moving in the direction of current. So again, it will be positive. So I into R2. I into R2. Now again, we will ignore the battery. We will try to move in the current only. Again, we are moving in the direction of current. So it will be plus I into R1, right? Now that should be equals to the EMFs of the battery. Now what is the direction, original direction of the battery? So battery is trying to send the current in this direction. This battery is also trying to send in the this direction. So both are trying to send the direction through which we have completed our loop. So our loop was completed in this direction and both batteries are sending the current in the same direction. So it will be epsilon 1 plus epsilon 2. Okay. Now what we will do, we will just separate IR equals to epsilon 1 plus epsilon 2 minus I common R1 plus R2. Okay, so this is the equation number 1. Now we will apply the same thing in the KVL in loop 2. KVL loop 2 is very simple. So only one battery is there, epsilon equivalent, only one resistance is there, only one internal resistance is there. Again it is sending the current, so I current is exiting, I current should come back. First of all IR, and we are moving in the direction of current, so IR plus IRQ, that should be equals to the equivalent EMF epsilon equivalent. Okay, now or IR equals to epsilon equivalent minus I into R equivalent. This is equation 2. Now if you compare equation 1 and 2, both side has same IR on the left side, so what we can say that this must be equal to this. So comparing 1 and 2, epsilon equivalent must be equals to this, epsilon 1 plus epsilon 2, and R equivalent is basically R1 plus R2. Okay, that's it. Simple derivation, full marks. Okay, diagrams are compulsory. This derivation is very simple, but fortunately this is the most asked derivation. Okay, parallel one can also come. Again, parallel one I will not do in this lecture. Okay, parallel one you can check my derivation series where I have done all the derivations. So series 1 is most expected, that's why I am doing the series 1. Derive the expression for magnetic field at a point on the axis of a current loop. This is also very common and most expected. So here we have a current loop, we are trying to find the magnetic field on the axis of a loop. Okay, we will take the small element dl here and we will try to find the magnetic field at this point. This is say point P. The distance between the radius of the loop is R. The distance is say x. So this distance is R equals to square root of R square plus, so this distance is R, right? So it will be a right angle triangle. Right angle triangle means R square plus x square. Now if you consider a length dl here, this angle will be 90 degrees. Okay, there will be some internal angle phi, and the magnetic field in this case will be making an angle phi. Why we are writing dB? Because this is an element, current element, small element dl, due to which we are trying to find the magnetic field. Now if you consider diametric opposite point, there will be a dB in the opposite direction, exactly opposite direction, and having the same magnitude, so y components will cancel again, so only the x component will be left. Now in this case we will not do the 2 dBx thing, but we will only consider only 1 dBx, because ultimately that is not required in this case. In case of dipole where two discrete charges are there, that's why we had to do the 2 dBx thing, 2 EX thing. It is similar to that of the dipole. So only dBx we are trying to find. Now according to Biot-Savart law, this first dB is given by mu naught by 4 pi. Okay, I dl sine theta by r square. Okay, now sine theta is 90 degrees here. So 90 degrees sine theta means that sine is becoming 0. So you get mu naught by 4 pi. Okay, I dl by r square is capital R square plus x square. Okay, again dBx is basically again dB cos phi, right, x cos component. So dBx will be this entire thing mu naught by 4 pi I dl r square plus x square into cos phi. Now I am doing one cheating here, not super cheating. What I will do, I will find the cos phi and I will directly put it here. So what is cos phi here? Cos phi is from this right angle triangle. This is the angle phi. That means what is the adjacent side? Adjacent side is this one. So first we will write the adjacent side, that is r, divided by the hypotenuse. Hypotenuse is this one, that is r square plus x square square root, that is to the power half. Okay, this is cos phi. So we will directly, I will jump one step. So if you don't watch this video, directly download this PDF, you may not be able to understand what I have done over here. Okay, so r square plus x square to the power half. Okay, so this is the dbx. Okay, you have to practice this again and again. Okay, I have done this practice at least 10-20 times, but how many times you have done, right? This is a very important derivation. Now total Bx, total magnetic field, is basically mu naught by 4 pi I r divided by, this will multiply it, so it will be r square plus x square to the power 3 by 2 into integration dl. Okay, this dl is only varying, so dl is the small element. Now small element, if you take the small elements and if you add all the components, what you will get? You will get the total radius, total circumference. So the same formula will become mu naught by 4 pi, okay, IR by r square plus x square to the power 3 by 2 into dl. dl means 2 pi r. Circumference is 2 pi r. Now if you see that there is a cancellation happening, so the final formula is mu naught by 2, okay, r multiplied, so I r square divided by r square plus x square to the power 3 by 2. This is Bx. Okay, and in case they ask you to find the magnetic field at center, you have to put x equals to 0. Okay, but and that was never asked, so that is why I am not doing that. Okay, now let's move on to the next question. Derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. Let's see. So this is the two diagrams that is compulsorily you have to draw. There are no shortcuts. These two diagrams are common. Now why I am saying that there will be some unexpected questions in this year. Okay, so whatever expected questions, you have to practice them, so that even if this question comes, this is an expected question, you can still answer that. Okay, now so from there, from geometry, we can write that delta equals to I plus E minus A, and then A equals to R1 plus R2. These are the from geometry. Now by observing I versus delta graph, we can see that the angle of minimum deviation occurs when the angle of incidence I is equal to angle of emergent. Okay, so I is equals to E and R1 equals to R2 equals to R. That is delta M. So angle of minimum deviation is delta m, right? So delta m is equal to, if you put delta m equals to, instead of E, if you put I, then you get I plus I, that is 2I. So 2I minus A, or you get I equals to A plus delta m by 2. So remember the steps, very important. From there you can say that A equals to 2R, okay, from this one. So both of them are equals to R, so R plus R, 2R, so A equals to 2R, or you can say that R equals to A by 2. Okay, so then you can say that, okay, now what is the definition of refractive index? Refractive index of the medium of the prism with respect to the outside medium is given by sin I by sin R. So from there you can calculate the N21 is equal to sin A plus delta m by 2 divided by sin A by 2. This is the derivation that they have asking you. So very important, mathematically not super difficult, but steps you have to remember, little bit practice with it, so you can answer that question. Okay, now what is a rectifier? Explain the working of a full wave rectifier using the neat circuit diagram. Draw the input output waveform. So this is the diagram of the full wave rectifier, very common question. Positive half so rectifier is an electronic device that converts alternating current AC into direct current DC. Positive half cycle of the AC input. During the positive half cycle of the AC input voltage, the upper half of the transformer secondary winding becomes positive. Okay, diode D1 becomes forward biased and conducts, allowing the current to flow through the load resistor RL. Diode D2 is reverse biased and does not conduct. Okay, now negative half cycle, during negative half cycle of the AC input voltage, the lower half of the transformer secondary winding becomes positive. Diode D2 becomes forward biased and conducts, while the diode D1 reverse biased and does not conduct. Current again flows through the load resistor RL in the same direction as during the positive half cycle. So this is the diagram. So this is the input voltage, this is the output voltage. Okay, and the output voltage you are getting two halves. One is due to D1, another one is due to D2. So when the voltage is positive, D1 conducts. When the voltage is negative, D2 conducts. But both of them are sending the current in the same direction. That is why now all the currents are getting in the same direction. Okay, and as you see that this is a fluctuating DC. This is not a constant DC. Constant DC should be a straight line like this. Okay, constant DC should be a straight line. Now next, what is a half wave rectifier? Explain the working of a half wave rectifier using neat circuit diagram. Also draw the output voltage. So half wave rectifier is an electronic circuit that converts alternating current AC into direct current DC by allowing current to flow only during the one half cycle of the AC input signal. The other half cycle is blocked, only half of AC waveform is used. Okay, now positive half cycle, during positive half cycle of the AC input, the P side of the diode is positive with respect to the N side. Okay, the diode becomes forward biased and conducts current. Current flows through the load resistor RL in one direction and the voltage across the load is positive. During the negative half cycle of the AC input, the P side of the diode becomes negative with respect to the N side. Okay, the diode is reverse biased and does not conduct. No current flows through the load resistor RL and the output voltage is 0 during the half cycle. Okay, so this is the circuit diagram, this is the output voltage. So only one half of the diode is conducting, other half there is no diode, so no conduction happening. So you are getting one positive, then one maximum, then 0, another maximum, then 0, like that. Okay, this is the half wave rectifier. Now write three differences between intrinsic semiconductors, extrinsic semiconductor. Draw the energy band diagrams of N-type and P-type semiconductors at temperature T equals to T greater than 0. So intrinsic semiconductor, pure semiconductor with no impurities. Extrinsic semiconductor, semiconductor doped with small amount of impurity to improve conductivity. Okay, now this is a question which might come as a 2 marker as well. Okay, 2 marker and 3 marker, and maybe they will change the half wave full wave rectifier pattern this year. There was a chance that there will be some new questions coming this year. One of the question is this. Another question from this chapter I will be doing during my live session. So if you want to know about that question, you can join my live session tomorrow and we will find out what are the other question. Okay, so a pure semiconductor with no impurities, a semiconductor doped with a small amount of impurity to improve the conductivity, and then charge carriers, equal number of electrons and holes, unequal number of charge carriers, majority carriers, electron in N-type holes, electrons in N-type and holes in P-type. Okay, and minority charge carriers. Okay, so majority charge carriers are electrons in N-type and holes in P-type. Okay, other charges are minority carriers. Okay, conductivity, low conductivity at room temperature, and conductivity is generally high for doped semiconductors. So P-type and N-type usually are highly conductive, whereas normal intrinsic semiconductors are not very highly conductive. Okay, now we will be solving some this is the some band diagram. Okay, this is for N-type, Here the electrons are getting donated from this level to this level, so that is why this is called donor level. Okay, as you can see that normally the band gap is very high, but the band gap from the donor level is very low, so electrons can easily jump from donor level to the conduction band, giving a lot of free electrons. Whereas in case of p type, what happens is there is a acceptor level. What this acceptor level does is that it accepts electron from the valence level to the acceptor level, so electrons only need to jump this much energy, so lot of holes are created in the valence band. So lot of holes means lot of conductivity, right? So this is dependent on acceptor level, this is dependent on donor level. So if you see any objective questions that donor level is in case of p type, n type, pn type, so you have to remember that donor level means it's a n type, okay, whereas acceptor level means it's a p type. Okay, so these are a very common type of MCQ questions that also come in your final exam. Now we'll be solving some numerical questions. I have handpicked only 2 chapter numerical questions. One is from alternating current, one is from ray optics, so that most of the crowd who are watching this video can get benefit of it. And other chapter numericals I will be solving in the live session day after tomorrow. There will be a live session for numericals only. So if you have any doubts on numericals and if you want me to solve any specific numerical, don't forget to mention that in the Google Drive link shared in the chat. Also it was shared in the our WhatsApp channel, so check that drive link, and obviously there is a Google form available. You mention the subject physics and you have a doubt in the numerical, so you can mention the whatever numerical questions that you have doubt on. Okay, so I hope that helps. So I will be solving those numericals. Don't mention too many numericals, at least one numerical, one student is fine. I will try to take up as many as possible, okay, as much as time permits. But in my opinion, if you are not super confident, don't try current electricity chapter. We will be getting numericals from ray optics, optical alternating current, one numerical from the first 2 chapter, electric field and charges, and electric potential and capacitance. I have solved first 2 chapters I have covered in my full numerical video. Here I will be mostly discussing alternating current and ray optics chapter. These 2 are very common questions coming from these 2 chapters, and the electric field and electric charges will be your backup option. One of them will be your backup option. If you want, you can stop the watching video here. You can go and check the numerical videos where I have done a detailed analysis of the numerical section. Okay, so let's see the first numerical. Okay, a series LCR circuit connected to a variable frequency 240 volt source. So a series LCR, we have an L, okay, a C and an R. So we have an L, a C and an R in a circuit. And the frequency of the source is variable. You can vary the frequency. So frequency is variable. Voltage is fixed, 240 volt. Okay. The L value is 5 Henry, the C value is 80 millifarad, and resistance is 40 ohm. So millifarad means, just let me write it here, 10 to the power of minus 3 farad. Okay, millifarad means 10 to the power of minus 3, not micro. Determine the source frequency which drives the circuit in resonance. So the natural frequency, the frequency of the circuit, or the resonance frequency, they are all the same. So what is the formula for resonance frequency? The resonance frequency is calculated using the simple formula F is equal to 1 by 2 pi square root of LC. This is the formula for frequency, right? So what we will do, we will put the value 2 pi L is 5 Henry, and it is 80 into 10 to the power of minus 3. Okay, so this can be written as 8 into 10 to the power of minus 2 farad for our own benefit. Okay, so you will get this as 1 by 2 pi 5 8 is 40. So I changed it, so let me change it here as well. It will be 80 into 10 to the power of minus 2. Okay, now when you are doing the square root of 10 to the power of minus 2, the minus 2 will come out, so it will become 10 to the power of minus 1. Okay, and 5 8 is 40. This minus 1 will be going upward. Minus always goes up and becomes plus. Okay, so it will be 10 to the power of 1. 10 to the power of 1 means 10. So if you calculate this value, you will get around 0.25 Hertz. Okay, you will get the value as 0.25 Hertz. Check that out. If you get a different value, don't forget to mention that in the comments, sir, I got a different value. So last time while solving one of the ray optics question, I unfortunately I made a small mistake. So student was saying that I was confused. I was not confused. Only thing that I made was judgment of error. So that is why it is possible for you as well. Only one student commented like that. Okay, and it can happen with anyone when you are taking a very long session. For example, I am taking this is almost going to be 3.5 hour session. So at the end of the session, when we are taking this long session, there will be errors in it. Okay, now obtain the impedance of the circuit and the amplitude of the current at the resonating frequency. Okay, so this is the part A. Okay, now what is the impedance? Impedance at resonance. Impedance at resonance is very easy. This question is this type of question is very common in your PU board. Impedance at resonance is nothing but only the resistance. Okay, because we know that impedance means what? Impedance means square root of R square plus XL minus XC whole square, right? This is the formula for impedance. Now at resonance, XL becomes equals to XC, so XL equals to XC at impedance at resonance. So that means this term becomes 0. So Z is basically square root of R square, that is square, this is nothing but R. So at resonance, circuit is completely resistive, so it is basically only the resistance is there, not the XL or XC. So at resonance, all other terms vanishes, only resonance is there. So R is equals to 40 ohm. That is the impedance. Impedance and resistance are same. Now what is the current? So current is basically voltage, RMS current they have said, because this is RMS voltage. Okay, so don't worry about it. V by Z, so that is 240 divided by 40, that will be 6 ampere, that is 6 ampere, right? Now last part, determine the RMS potential drops across 3 elements of the circuit. So 3 elements of the circuit means we have to calculate VR. Now VR is nothing but the applied source voltage. You have to remember that it is nothing but I into R, that is I is 6, R is 40, which should come out to be 240 volt. Okay, now also while calculating the XL or while calculating the voltage across L or R, L or C, you have to remember that voltage across L will be equals to voltage across 3. At resonance, both voltages are same. So if you calculate only one of them, that will be sufficient. Okay, if you only calculate VL, you can calculate VC as well. Now how to calculate VL? VL, this is a new thing. So VL is XL into I, current I we have already calculated. Now you have to calculate XL. Okay, so XL, to calculate XL, you have to use this frequency. Okay, so obviously XL is basically 2 pi F into L. So 2 into 3.14 into 0.25 into 5. Okay, so this will be the value of XL. Let me try to calculate it. 10 divided by 10 into 10 divided by 4. 10 divided by 4 means obviously 2.5. 2.5 into 3 will be 7.5 7.8 ohm. Okay, 7.8 ohm. So VL equals to VC equals to 7.8 into 6, whatever value you will get. Let me see the value. So you will get, yes, it will be 47.5. Okay, this will be the approximate value of the VL equals to VC. You can calculate any one of them, Excel. Okay, then you can calculate calculate XC as well. XC's value will be the same. So that way you can skip one step. Okay. Now you can use the calculator to calculate the exact value. It is my approximate value because I have solved it before using calculator. So answers are written over here. Okay, so 0.25 Hz is the frequency at the first, 40 ohm and 6 ampere is the answer for the second, and 240 volt and 47.5 volt is the third answer. Now not all the three parts will come in your board exam. Any of the two parts will come. Okay, first part generally comes common. Obviously without solving the first part you cannot solve the other two parts. So first part and second part I have seen coming in the board exam. Third part might come in this year. So that is why I have given the third part as well. Now let's see another question. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitance 20 microfarad. Now the capacitance value is different. Always it will be the same, similar story. Story for AC circuits are similar. Okay. Only thing is that you have to use a calculator to find the final value. Okay, so if you can do that, you can solve a question from alternating current. That's why I suggest you to solve questions from using from AC. Okay, same formula, same values, everything will be almost same. Okay, and resistor of resistance 40 ohm, another 40 ohm resistance. The AC source of 200 volt 50 Hz is present in the circuit. Find the impedance, also find the resonant frequency of the circuit. This is also very common question. Okay, now first part to calculate the impedance is slightly longer. Resonance frequency is obviously the same formula. It will be easier. So first, obviously to find impedance, whenever we are finding impedance, we have to calculate XL. What is XL? XL is 2 pi F into L. Now what is 2 pi? 2 into 3.14 into F is 50 Hz and L is 5 Henry. Okay, so 5 to the 10, 10 into 5 is 500. So it will be 500 into 3.4. 500 into 3.14. So it will be 1570. This is XL. XC will be 70. That's why I am saying 70. Okay, you can use the calculator to find the value. Okay, does not matter. So XC equals to 2 pi F C. Now in this case C's value is microfarad. Okay, so C calculating XC is slightly difficult. XL is straightforward equation, but XC is 1 by no. That is why student sometimes gets confused, but don't get confused. If you practice 2-3 problems how to calculate XC, that is the major trick in this case. So 2 into 3.14 and the values are given such that you cannot directly solve it without using a calculator. Okay, if it is a competitive exam, then they would give you the frequency such that it gets cancelled. But because you are allowed to use simple calculators, not scientific calculators, that is why I am using 3.14 instead of pi, and C value is given 20 microfarad. Microfarad means 10 to the power of minus 6. Now this minus, as I said, 10 to the power of minus in the division don't like to stay in the division, it goes up and becomes positive. Okay, now this is the thing. So 2 into 50 is 100, 100 into 20 is 100 into 20 is 2000. So it will be 10 to the power of 6 divided by 2000 into 3.1. Okay, so it will be, so now 3 zeros can be cancelled from here. So it will be 1000 divided by 3 to the 6.28. Okay, 6.28, I think 100 something, 150 something. Okay, 150 approximately. Okay, 160 say, because 150 into 6 is 900. Okay, 150 into 6 is 900, so maybe 160 will be the answer. You can calculate again. I am not using calculators. I don't remember the answer for this question as well. So now you have to calculate the impedance Z. So formula for Z is, as you know, very simple, R square plus XL minus XC whole square. Now if you see that XL is greater than XC, so XL minus XC. In case XC is greater than XL, XC minus XL. Whoever is bigger, he has more money, so he will be coming first. That is the major thing. So R is 40 square plus 150 570 minus 160 whole square. So it will be approximately 40 square plus 1410 whole square. It will coming out to be very close to 1418 if I remember correctly. As I said, I solved this question very long time. We will check the answer at the end of this solution. Okay, so this is the answer for this. So you can't use all this using calculator. Okay, only thing that you have to do it step by step, because scientific calculator is not allowed. So in the rough sheet, what you do, you calculate 400 square. Okay, what is the 400 square? 40 square. 40 square is 1600 plus whatever is the square of that number, write it down here, then add them in the calculator. Okay, then what you do, you just take a square root of that value, whatever final value you get. I think you can do this much in one go. Maybe square root you have to do it another time. Okay, so write down those values in your notebook and then do the square root. It is easily doable, slightly longer, but obviously sure shot. That is why I say that solve problems for alternating current. This is a sure shot problem. Okay, without much difficulty. Now again, what is the resonant frequency of the circuit? Resonance frequency is F reso is basically 1 by 2 pi square root of L into C. So again 1 by 6.28 into 2 pi is 6.28, don't worry. L is 5 and C is 20, 10 to the power of minus 6. Okay, so 1 by 6.28 into square root of 100, 10 to the power of minus 6 comes out, it will become 10 to the power of minus 3. Now as I said, 10 to the power don't like to stay in the denominator, they goes up, becomes positive. So 6.28 into square root of 100 is 10, so you get 1000, or you can just cancel one of them. So you get 100 divided by 6.28. So I think it will be whatever value it is, 1.6. Okay, close to 1.6 hertz. Okay, sorry, close to 16 hertz. How much is the answer? 16 hertz. Yes. So even if I am doing it almost approximation, okay, without using any calculator, still I can solve the questions based on the practice. Okay, you can calculate the exact value using calculator. So it is 1412. I wrote it 1418. My mistake. It will be 1412 ohm. Okay. Also you get marks for the steps. So even if your final answer is incorrect, you may lose out 1 mark for that. Okay, unit is very, very important whenever you are solving. For example, frequency is hertz. Okay, impedance or resistance is ohm, current is ampere. Okay, the units are also very, very important in this case. Now let's move on to question number 96. We will be solving till 100. Okay, so 4 more questions left. The sinusoidal voltage of RMS value 200 volt and frequency 50 hertz is applied to a series RC circuit in which R is 3 ohm, C is 800 microfarad. Calculate impedance of the circuit, the current through the circuit, phase difference between current and voltage. Okay, so again this is a very common question. So first we will do that, we will calculate the impedance. Now there is no L here, so only C is here, so that is one benefit. We only need to calculate XC. What is XC? XC is 2 pi FC. Okay, so that is 1 by 2 into 3.14 part A. We are solving the part A first. Okay, 3.14 into frequency is 50 and C is 800 microfarad. Microfarad means again 10 to the power of minus 6. So 10 to the power of minus 6 does not like to stay in the denominator, so it will go up in the numerator. Now simplify it. So 10 to the power of 6 divided by 5, 50 into 2 is 100, 100 into 800 into 3.14. Okay, so how many zeros will cancel? 1, 2, 3, 4. 4 zeros will cancel. So it will be 100 divided by 8 into 3.14. 8 into 3 is 24, and it will be almost equals to 25. So the XC value will be very close to 100 divided by 25, that is 4 ohm. Now XC is in ohms. Okay, very careful. Now what is the value of resistance? Resistance is given by 3 ohm. And what you have to calculate? You have to calculate the impedance. Sir, there is no XL here, no inductor here. How can I calculate impedance? It is very easy. One part is missing, right? So you can relax and enjoy. Okay, it will be only R square plus XC whole square. In the same case, if they give you RL circuit as well, in case of RL circuit, it will be R square plus XL square. Okay, XC is 0. So if you put the XC value 0 in that equation, what you will get? You will get only this value, right? Negative value will be negative square is positive square. So just remember one formula and use the corresponding value. If there is no L, that means XL is 0. If there is no C, XC is 0. Only one formula is sufficient. Okay, it's the same formula that we used for the last problem. Now it will be 3 square plus 4 square. Okay, so 3 square plus 4 square is equals to what? It will be square root of 25, that is impedance will be 5 ohm. As simple as that. Okay, even without using calculators you can solve this question. Now the current through the circuit, how to calculate the current? Part B, current is nothing but voltage divided by impedance. Don't divide it with the resistance, you have to divide it with the impedance. Very careful. So voltage is how much? 200 volt. So 200 divided by 5, okay, that will be 40 ampere. So current is 40 ampere. Next, phase difference between current and voltage. Phase difference, how to calculate phase difference? Phase difference formula is phi equals to tan inverse XL minus XC by R when XL is greater than XC. Okay, or tan inverse, these are all alternating formula. This is 1, this is 2, tan inverse XC minus XL by R if XC is greater than XL. Okay, the only thing that you have to remember is that based on who is greater, the formula slightly changes. Okay, now in this case XL is 0, so obviously XC is greater than XL, so we were using this formula only. So phi equals to tan inverse, if you put XL equals to 0 in this equation, then you will get XC by R. Okay, so what is XC? XC we have calculated 4, so it will be tan inverse 4 by 3. Okay, tan inverse 4 by 3 is 53 degrees. But don't worry if you don't find this angle using your table, sine tangent table, you can leave the answer at this point as well. You will get full marks. Okay, 4/3 is a very common value, so that is why I have written 53 degrees. If you are preparing for any competitive exam, then you are aware this is the another angle other than 60, 30, 45, 0. This is also very common angle, 53 degrees. Okay, so let's see the answer. So this is 5 ohm, 40 ampere, 53 degrees. Okay, very easy question. Now let's move on to the next question. An object, now we are solving few ray optics question. Okay, last 3 questions, 97, 98, 99, last 4 questions are from ray optics. Now one question is not from ray optics, that is a surprise. Last question, question number 100, is not from ray optics, that is a surprise. An object is placed at a distance 0.3 meter from a convex lens of focal length 0.2 meter. Find the position and the nature of the image formed. Also find the distance through which the object should be moved to get an image of linear magnification -1. I think this is one of the previous year question. Okay, so object placed at a distance of 0.3 meter. Okay, so object placed at a distance from a concave lens, convex lens. Okay, convex lens. Okay, so my mistake, I thought it is a concave mirror. It's a convex lens. Placed at a distance 0.3 meter from the lens. So distance is, object distance is 0.3, and as I said, object distance is always negative, 0.3 meters. And what is the focal length? Focal length is 0.2 meter. Focal length for a convex is always positive, 0.2 meter. And find the position and the nature of the image. Very easy question. So 1 by V minus 1 by U equals to 1 by F, or 1 by V equals to 1 by F plus 1 by U. So if you do that, you will get V equals to UF by U plus F. Okay, now you have to put the values. So what is U? U is minus 0.3. U is minus 0.3. What is F? F is plus 0.2. Okay, and U is minus 0.3 plus 0.2. Okay, so sign is very important at this stage. Till this point, you reach this point, sign is not important. Once you reach at this point, sign is very important. Okay, so now you will get minus 0.3 into 0.2 divided by minus 0.3 plus 0.2 is minus 0.1. So minus cancels. Let me cancel one of the decimals. So 2 into 0.3, that is 0.6 meters. So now what is the sign of the object image distance? It is positive. So image is formed somewhere on the other side. Other side means definitely it's a lens. The image is obviously inverted and real image. So the nature is real and inverted. Now they have asked you the second part, which is actually very easy. Don't worry, the question looks difficult but the answer is not. So how much distance through which the object should be moved to get an image of the magnification -1. So magnification -1 happens when object is placed at U equals to 2F, that is 2 into 0.2, that is 0.4 meters. Okay, so if the object distance is 0.4 meters, then we get magnification -1. So therefore the object should be moved by 0.4 is the final distance, 0.3 was the initial distance, so it should be moved by 0.1 meter. So the object should be moved by a distance of 0.1 meter to get the desired magnification. Let's see the answer. So 0.6 meter, it's a real and inverted image, and it should be moved by a distance of 0.1 meters. Now, two lenses of focal length 0.2 meters and 0.3 meter are kept in contact. Find the focal length of the combination. Calculate the powers of two lenses in the combination. So we know that when two lenses are kept in contact, the equivalent focal length 1 by f is basically 1 by f1 plus 1 by f2, or f equals to f1 f2 by f1 plus f2. Okay, now both are given with the sign of the lenses. Sign of the focal length is not given, so they just mention two lenses. So we will assume that whatever sign is given over here, that is the sign of the lenses. In case they mention one concave, one convex, then for concave you have to take negative, for convex you have to take positive. Okay, so be careful, the same question might come in a different form. 0.2 into 0.3 divided by 0.2 plus 0.3, so it will be 0.2 into 0.3 divided by 0.5. so we will remove one of the decimals, so it will be 0.6 divided by 5. So how to get rid of this? We will multiply 2 in the numerator and denominator. 1.2 by 10, that is 0.12 meters. This is the equivalent focal length. Okay, now what is the power? Calculate the powers of two lenses in combination. Power of the two lenses and combination. So power of the two lenses means you have to calculate P1. P1 is 1 by F1. So remember that this formula is valid when the focal length is in meters. Okay, fortunately here the focal length itself is given in meters, so we don't need to worry too much. We can use this same focal length. In case it was given 20 centimeter and 30 centimeters, then you have to convert it first into meters. Okay, so let's put that value 1 by 0.2. Right, so 0.2 means it will be 10 by 2, that is 5 diopter, 5 plus 5d. Okay, remember that generally we add a sign for the power. Okay, because plus is sign, so we will add plus 5d. Now what is P2? P2 is 1 by 0.3. So it will be 1 by F2, obviously it will be 3.33 diopter. Unit is diopter. Now what is the total power? Total power is basically P1 plus P2. You can use this formula or you can use 1 by F as well, whatever you like. This is easier because we have already calculated the powers, so we just need to add them. So it will be plus 8.33 diopters. Okay, easy. So I think the answer for this question is wrong. Okay, now let's move on. A prism of angle 60 degrees produces angle of minimum deviation 40 degrees. What is the refractive index? Calculate the angle of incidence. Okay, so we have first of all, what do you know about minimum angle of deviation? So minimum angle of deviation is basically 2i minus a. So from this formula you can calculate the angle of incidence, but we will first we will calculate the refractive index, which is basically sine a plus delta m by 2 divided by sine. Now in such cases you might need a tangent table to find the exact value. Okay, now Tangent table is very easy to find. There will be a sine, cos, tan, cot, cosec, sec will be mentioned, and the degree values will be given in some division. Okay, they generally don't give very too complicated degrees. Okay, if you see that value, degree to value is very easy, value to degree sometimes is difficult. Okay, you have to check the value, then you have to correspondingly find the degree answer, but that is also very easy. Okay, so sine a plus delta m by 2, sine a is what? A is 60 degrees and delta m is 40 degrees by 2 divided by sine 60 by 2. Okay, so it will be sine 50 by sine 30. Okay, sine 50 is approximately sine 4 by 5. Approximate value I am taking 53, sine 53 degrees 4 by 5. Sine 30 is obviously half, so it will be 8 by 5, that is 1.6. It will not be 1.6, it will be slightly less than 1.6, but approximate value is no problem. Now you have to calculate the angle of incidence. Angle of incidence can be calculated from this formula. So 2I is equals to A plus delta M, and I is equal to A plus delta M by 2. So what is A? A is 60, delta M is 40 by 2, that is 50 degrees. Okay, this is the 50 degrees. Let's see the answer. 1.53. Okay, I made a small mistake. It will be 1.53. So if you use, if you find, even if you show 1.6 after reaching here, then also you will get the full marks. Don't worry about it. In case the angle is not super simple 30, you can take the nearest value. For this example, I have used sine 53 degree value. Okay, so if your angle is close to say 35 degree, you can choose to use the value 37 degree as for example. Okay, which is also have a nice value 3 by 5 for sine. Okay, so based on whatever angle you are getting, and correspondingly you can choose the correct answer. Okay, now this is a trick that I taught you. Now anyway, you can use the exact tangent table and to find the exact value. Now last question, surprise question. This is based on the last chapter for your model question paper 3, where this type of question was there in photoelectric effect. So I thought, okay, let me check NCERT, and I found one question, one good enough question that might come in your PU board exam, because previously there was a trend that NCERT questions were coming in your board exam. So I have taken this question from your NCERT textbook with slight modification. NCERT textbook question was slightly difficult with the values. I don't like with the difficult values, so I have just reduced the values so that I can solve it quickly. So light of the wavelength 496 nanometer is produced by an argon laser, which is used in the photoelectric effect. When the light from this spectral line is incident on the emitter, the stopping or cutoff potential of the photoelectrons is 0.34 volt. Find the work function of the material from which the emitter is made. Okay, so first of all, what is given? The stopping potential V0 is given 0.34 volt. Okay, so we know that the stopping potential EV is 0.34 volt, means EV0 is basically 0.34 EV. Okay, if you multiply with E, you get in the EV unit. Okay, so EV unit is the stopping potential, right? Because EV unit will help you a lot if you solve this problem in EV unit. Now next is, what is the energy of the incident photon? Energy of the incident photon is obviously h nu. Now h nu is not given. What is given? Given is lambda, so hc by lambda. Okay, now here you can put the value of H, you can put the value of C, you can put the value of lambda and calculate it in joules. Again, then in that case you have to calculate EV naught into joules as well. So multiply it by 1.6 into 10 to the power of minus 19. Now I am going to teach you a shortcut method. What is that method? You have to remember that value of HC is basically equals to 1240 EV nanometer. So if the wavelength is given in nanometers, okay, if the wavelength is given in nanometers, only thing that you need to do is you need to put 1240 over here and the value of whatever wavelength they have given in the denominator, and the result will be automatically converted into EV. That is as simple as that. Okay, so that is why I say I change the value 496 slightly, okay, so that I get a value of exactly 2.5. okay, so if you divide it you get 2.5 EV. So now this is, you have to remember, HC value is 124 EV nanometer. Okay, if you remember that, your life will be very, very simple. Nanometer from numerator and denominator will be cancelled, so only we are left with EV. So what is the Einstein's equation? So Einstein's equation says that E equals to the energy of the photon is basically a stopping potential plus phi naught. Phi, okay, so phi is basically equals to E minus EV naught. So this is a very, very simple question. If you try to solve it in a simpler way, you can make it complicated and make it a very little long answer question, but if you know tricks, you can simply answer it very simply without doing a lot of mathematics. Okay, only thing that you have to remember is this HC equals to 1240 EV. Now if you are preparing for KCET exam or any other competitive exam, this is the value that you have to remember. Even if you are not preparing for KCET exam, maybe you are preparing for NEET exam, this value is very, very handy. You have to remember that value. Okay, now tomorrow I will be doing a PYQ session, top 50 PYQ questions, which you will be some question, obviously 2.16 EV is the answer for this question. Now PYQ session will be some questions will be again from this class. Some questions will be that will be very selected questions. Here we have done 100 questions. Tomorrow we are only going to do 50 questions. Okay, 50 theoretical questions. I am not going to do any numericals again. Numericals I will be doing day after tomorrow in a live session. So whatever your doubts regarding numericals, post in the comment. Okay, I will try to solve as many numericals as possible during the session. And tomorrow will be also a live session with all of your theoretical doubts. So if you have any doubts in theory, sir, I don't understand this concept, can you please explain? I will explain that. Okay, so this will be based on the doubts only. Okay, and there will be, don't ask me, sir, which question will come. Okay, which chapter I should study. I have already explained it, right? Yesterday's video was there. What are all the important chapters from where you have to study? So everything was explained in that video. Gap strategy is also explained. So I hope you are following that gap strategy. So tomorrow I will see you in the live session along with top 50 MCQ, top 50 PYQs. Okay, so everything will be done tomorrow. So there will be two videos, one is recorded, one is live. Live timing I will announce it through my WhatsApp channel, through our WhatsApp channel, as well as in our YouTube channel as well. So keep following us. If you have not yet subscribed to our channel, definitely you want to subscribe to our channel. Also share with your friends about the live link whenever it is going to live tomorrow, so that maximum number of students come in and I get some encouragement that okay, the students are listening. I will be enthusiastic, I will be more ready to do the class with full energy, right? See you tomorrow. Till then, bye.